I would like to extend my thanks to all of you who are present here to attend this training program from all over the country. So, first of all, I would like to invite our principal sir, Dr. K.V. Rao, under whose leadership, visionary and dynamic leadership, we all are working, and we are moving towards step by step towards our vision, which is excellence in technical education for women empowerment. So, sir, kindly address our participants and motivate with your words.
Good morning, everyone. I think I'm audible.
Yes, sir.
Okay, thank you. Thank you. Good morning, everyone. First of all, I would like to welcome all the participants who had joined this program on GIS for architecture and civil engineering. Basically, this is not only for architecture and civil engineering branch. Other people also can join this, and I had seen that number of courses over and above these branches, people have joined and taken a lot of interest in this program. On behalf of AICTE and the Women's Polytechnic College Bhopal, I would like to welcome all the eminent speaker, Dr. Martin from MPSCTC Bhopal, Dr. Katiyar, Professor of Management Bhopal, Dr. Chaure from Indore University, and Dr. Seema and Dr. Sharma from Udaipur University, Dr. Saha from SPA Bhopal, as well as Mr. Praveen Sharma, Deputy Director, GIS and RS. We had already included this GIS topic in our architecture department in Madhya Pradesh Technical Education. As far as I have knowledge, it is not included in civil engineering department. So I would like to request the participants of Polytechnic College from Madhya Pradesh Civil Engineering Department to kindly go through this workshop, learn a lot, and then try to incorporate this thing in the civil engineering syllabus also, so that the students will be benefited a lot. I hope this will be a very successful program for staff as well as the students. I wish you all the best, and I would like to congratulate all the coordinators and the team who is working behind this program. Thank you very much, and wish you all the best. Thank you.
Thank you so much, sir, for your encouraging words. Now coming back to the topic, GIS, Geographic Information System, it is being extensively used by architects, civil engineers, and in many disciplines. The basic ability which makes it most popular, it's giving anything a special context, whether the in one and all, like we see in many fields, the GIS is being used for presentation of data and analysis, and then like you can make very interesting presentations by using this software. So if we see the GIS softwares in market, QGIS and ArcGIS, these are the two leading, I can say, leading softwares in the industry. And during this course, we will be focusing more on QGIS, which is an open source software. And if we talk about the skills sets required or the functioning of the software, both are quite similar to each other. So if you learn one software, you can very well explore the another one. And but moreover, will be touching ArcGIS also in our last sessions. And I hope you will find all the sessions very interesting. And by the end of this training program, I wish that everyone will be skilled to use and suggest some measures to include this subject in their curriculum as well. So now I would like to hear from some participants. Can you all share your if you have any experience in this field, particularly in GIS, or what are your expectations from this program? Can we hear
all of you?
All of you? Yes, Meena.
Myself, Meena Kumari, working as Associate Professor at Tyagaraja College of Engineering, Madurai, Tamil Nadu. Actually, my research is towards climate change vulnerability assessment. So I'm in need of the understanding of the working of QGS. and I'm learning it through some other mode also. So I find this will be very much useful for me. So thank you for organizing such kind of short-term training program. Actually, it's neat for the hour for me personally, and I hope I'll also educate my students, and I can also guide others in this because I went through the agenda, program schedule, and all, and it was quite interesting. And I think it will give an overall overview of how we can go about it with Qgis. So I hope it will be very much helpful for me also, and in turn, I'll also help my students and other PG scholars to go about their this one. Thank you so much for organizing this, and thank you, ma'am. I wish all
Thank you.
the
Thank you, Meenakshi.
best for the success of this program. Yeah.
Thank you. Any other?
Good morning to one and all present over here, ma'am. This is E. Lakshmi. I have studied in Pondicherry Engineering College as an environmental engineering, and afterwards I've worked in. Presently, I'm working in Huzur PMC Tech. 10 years before, I have been worked through this GIS software. I have learned actually ArcView GIS. So after that, from then I've had no idea about it. Working in Orville, I have gathered so many details, and I used to store all the details in ArcView.js mapping, and then it will be retrieved. So this part alone, I have been worked so well for 25 communities. But afterwards, I couldn't get this kind of an opportunity to attend such kind of an FDP or STTP or whatever. So might be this is very very useful for me, so that I might grab from this FTTP, from this meeting. I can also help to my students in future, ma'am.
Thank
So
you.
thank you very much for this giving me this opportunity, ma'am.
Thank you, Jilakshmi. Anyone other from participants would like to share their experience and knowledge?
Yeah, hello everyone. I'm Apurv. I'm from Bhopal, Central India. I'm working with Asian Development Bank currently for designing some urban design guidelines for coastal towns in Bangladesh. And through this exercise, I'm expecting to learn how to map these all vulnerable areas, and how to get a better projection of whatever data we collect and whatever information we gather on site and off site. Thank you.
Thank you, Apu. Tariq sir, can you check Dr. Shafiq Mateen has joined or not?
Okay, ma'am. Please repeat. Okay, ma'am. Actually, we are waiting for our guest, expert for this session. He's not in the meeting. So I request anyone from the participant want to share their experience and expectation from this STTP program. Please go.
Everything is. Our expert is joining us in a while. Meanwhile, can we discuss can we hear from any of the participants about their expectations or whatever they want to share?
Yes, ma'am.
Our expert is joining us in 5 minutes. Meanwhile, we can have some discussions on like if someone wants to share their experience.
Hello, good morning, everyone. I would like to add something in this geographical information system as TTP. As I did my BArc IOGN School of Architecture and did MArc from SAPTE University, little bit I really confused between this geographical information system because I used to uh, use software like AutoCADs and Revits, but I would like also learn to something for really helpful for me in field like developing uh, uh, what you call metropolitan region or what you call development plans. So, madam, can you give me some brief how this course will helpful for me?
Okay. So you are already well versed with the software?
No, no. I just in my MArc class I used this ArcGIS software for a
Okay.
while, but I'm not using this software QGIS. But I'm curious to know about the QGIS and all
Okay.
these practices.
So if we have used ArcGIS, so you will feel more comfortable while using this software. The advantage of QGIS is the very important one is that it is free of cost available. Like you can download it free of cost, and the functions and results are more or less of same quality.
Okay, okay,
So this
madam.
is the advantage over ArcGIS. But obviously, ArcGIS has some special features which can be explored later.
Okay, okay. So, ma'am, we can do also this analysis part or in this QGIS like in early days I worked with some urban development firm. So they have this data, Sensex data, and this Sensex data correlated with this what you call spatial data.
Mhm.
Then they do some kind of means analysis wala part ki by 2001 Sensex this then this much population increase and these are the projections. So can we doing analysis wala part in this QGIS?
Yes, sir. This is all about, sir, about the software only. Such analysis is possible by using either QGIS or ArcGIS. Like both are, as I said, both are leading softwares in the industry. So people are using both softwares.
Okay.
Yeah.
क्योंकि because of this ArcGIS it is very costly software and
Yes.
mostly this is not a open source software. So somewhere we feel some hurdle in the kind of abstract data from means from this ArcGIS. So uh, that's why we right now we do not use this ArcGIS because we do use Autocad and Excel sheet for AutoCAD for mapping and Excel for what you call
Mhm.
analysis.
Mhm.
So,
But there are limitations of analysis part in AutoCAD map.
yeah, very limitation, and you cannot create very big what you call map on AutoCAD, and the
Hmm.
file also get heavy. So we have very limited limitation in this AutoCAD. Actually, if we want to create one city development map, so we create some pockets, or we can join in XREF system. So then how this can work as in AutoCAD. But I'm very curious to learn this software QGIS, and I really interested in this. And to thank for you also to create such kind of webinar or workshop.
Thank you so much, sir. And I wish that all the expectations of the participants they are met with this course. So, as you raised the question about the analysis part, so we'll be covering. I'll just go. I have actually shared the schedule also in the group, but you all must have seen the like it covers. We start with the fundamentals of GIS and then application of GIS in civil and architecture and planning field, then map projections, then georeferencing concepts and so on. Again, if I say uh, all such analysis like filter queries, special selection, things like that, like everything is there, and we'll also cover application of you can say a special feature that is digital elevation model of GIS software. So we'll go through that and we'll see that also, and we'll end with introduction to ArcGIS. So that if you are well versed with QGIS, and as I told, the functioning is more or less similar, so you can very well will be able to explore the ArcGIS also. So okay, I really wish and truly wish that everyone will find all the sessions very useful, and I really expect a very wonderful and successful training program. Dr. Shafiq Madin has joined, sir. Have you joined, sir?
Yes, I'm here.
Okay, so please, all the participants, please join me in welcoming our very first speaker of the day, and the training program, Dr. Shafiq Mateen. Let me say a few words about Dr. Mateen. Dr. Shafiq Mateen, he's currently working in MP SCDC, that is also called Map IT, as Remote Sensing Manager. Earlier, he has worked as research scientist, Dublin, Ireland. Dr. Shafiq Mateen, PhD in geoinformatics from IIT Kharagpur, and a renowned scientist of his field, and visiting professor of various national and international institutes and universities. Dr. Mateen has around 15 years of experience. He started his career as a scientist at Ministry of Earth Sciences R&D Center located in Chennai, and later joined as scientist at Ministry of Food and Agriculture in Dublin, Ireland. He is among a very few Indian scientists who is also a member of the Royal Ecological Society, London. Currently, he is working in the State Remote Sensing Division of MP SEDC, Bhopal, Madhya Pradesh. He is an author of 5 books and more than 50 journal articles. He is also editor of many international journals. He has delivered many international talks in universities like Israel, Turkey, Spain, France, Ireland, UK, etc. I am very much delighted to welcome Dr. Shafiq Mateen as one of our speakers today. Please, sir, take the charge of the session. Thank you for joining us.
Thank you very much, Randhana, for your nice and kind introduction. As ma'am said, I'm Dr. Shafiq Mateen. I am working as manager of Remote Sensing Division in MPSCTC, which is earlier called as Map IT. So, as I have told that there will be a session on the fundamental of GIS today, and I was a little worried about who will be my audience. So, because to start first, if it is better if I know who are listening me. So, if madam, if you can tell me also what is the major chunk of audience today who's listening to my lecture today, that would be great for me to take thing in a way which is basically required. So, madam, can you just elaborate me? I mean, a brief introduction who is in the audience today?
Sir, my voice is there. Voice is
Yes.
coming. Okay.
Yes.
Okay. Participants, they are a group of architects, civil engineers, research scholars in field of in various fields, and mostly from architecture and civil engineering, but some of from pharmacy and electrical engineering also. Like very few participants from that discipline.
So can I expect like they have a little bit of exposure to GIS and related stuffs, or shall I have to start with like very grass level?
I think, sir, you should start with very grass level.
Okay, that would be
Yeah.
great. Okay, so I will be sharing my screen now. Is my screen visible to all?
Yes, sir.
Okay. Yes, today we will talk about the fundamental of GIS, and that will cover the basics of GIS and its data source like remote sensing, GPS, and application areas of GIS. And as most of you are students, I will also cover a little bit about the job perspective related to GIS and remote sensing. So as you know,
Excuse me, sir. Excuse
sorry.
me, sir. So just I want to correct one thing. Like participants are faculty and staff members from technical education and from industry. So their basic discipline is civil and architecture.
Okay.
Yeah. Yes, sir. Thank you.
So okay, so let's start. So I will be covering the fundamental of GIS, and there I will be talking mostly about GIS and what makes a GIS working, like what are the data source, what are the inputs, what are the formats, file formats, what are the storage system, and many other related things. And I will also be covering about the job perspectives related to GIS and application areas. So starting from the definition itself, like what is GIS? So as you can read also, GIS means a collection of computer hardware and software designed for computing, storing, updating, manipulating, analyzing, displaying, publishing all forms of geographically referenced information. So basically the word GIS, which is basically Geographical Information System, here also there is a word called geography. In definition also there is a term called geographically referenced information. So this is the core of everything. I mean to say this is the core of everything we will be talking about today, or what is GIS all about. Okay. So geography means geo means earth, as all of you know, and if it is referenced to a something, it's basically GIS. And how we reference this, that we will learn in the later slides. But whatever is there which is on earth and it can be referenced or linked to something is basically GIS. And the process where we use hardware and software which we use for capturing the information, storing the information, updating the information, changing and manipulating the information, analyzing, displaying, publishing, and all other forms of the information manipulation, that we call as GIS. People use, I mean, in several fields and several expertise, people use GIS for their office work, or their research work, or their application work, or daily use work, even for home related work also we are using GIS. But how and where, that we will see. So what to understand GIS, this is a typical GIS overlay or GIS map that has been overlaid on a Google map, and you can see there are some there is a square there where you can see there is a variation of color from red to blue and yellow and other. There are lines, there are polygons.
Excuse me, sir. Slides are not moving. Sir, can we see the presentation in full screen mode?
Not moving?
In full screen mode, sir. Presentation.
In slideshow.
Slideshow. Yeah, that will be better.
Yeah, it's already on slideshow.
Okay.
Actually,
Yes, actually, sir, your PowerPoint.
please share again. Try again.
Okay, I'll do that.
Stop sharing and then
Stop
start
sharing and then resharing.
select only the sliding PPT only.
Yeah,
Is
it's
it
perfect,
better?
sir. Yes, thank you, sir.
Okay. So I was telling about this map. So you can see there is a variation of color, which nothing but represents the height or the elevation, and there are lines. There are small blocks. So these lines are showing some road or channel or some contours, and the blocks are showing some building areas and built areas. So this is a typical example of a GIS map. Here you can see, like, there are multiple source of information. There are multiple source of data formats, which has been integrated in a certain or in a single map to combine the information for a single and meaningful view. Here you can see there are information related to a road, settlement or habitation, you can say, height of the terrain, and many other things like forest, water bodies, these things. So by overlapping all these information on a single platform, a user or a person or an engineer will be able to see or extract more information from the map. So GIS is nothing but collecting different file formats, collecting different earthly objects or different objects from in different data format and overlaying them in a single platform to extract information. So definition wise, this is like that. But when we will go in details, it is a little complex. Here also you can see typical GIS map. Here you can see there are red dots, there are yellow dots, there are blue dots in this map, which is showing the number of item purchased on a particular region, and the highest is showing in the red color. The areas where the purchase was high is showing in red color, and the areas where the purchase was low is showing in blue color. So it's also a kind of hotspot map, which we call it hotspot map, where you can see the distribution of purchase, which is a kind of typical example of a GIS overlay map or GIS map. Here the same thing can be represented in a hotspot map like this. Here you can see the land purchase density is highest in which we are showing in red color, and the lowest we are showing in the blue color. So this is again an example of the GIS maps. Again, if the map is if we are creating something from the earth, or the map we are creating from the earth where there are some elevation, like for example Himalayas or any other area where there is height, you can also represent that in a way where you can even see the elevation, you can see the depth in a single map, and which is more meaningful to see and interpret. So the thing is, then the thing comes, what is geographically referenced means, or why we call it geographically referenced, or what are the reference points for this geography or this earth. So these reference points are nothing but the longitude and the latitude. So in a very layman definition, you can say the earth has been divided in hypothetical lines, which are which divides or which separates the earth into different latitudes and longitude. And wherever you are standing on this on earth, you will have some latitude and longitude for that area. Any point in the earth where you are standing now, or you will be standing after 1 hour or before 1 hour, there will be some latitude and longitude for that area. So that is basically your reference to the earth. Like this is the point which is 42.3744 and 71.1166. This is your latitude and longitude where you are standing. Same thing you can see on your mobile app, or same thing you can see on your daily use application. For example, Google Maps, your Ola, your Uber, and the delivery boy which is using his mobile phone to deliver your food on Swiggy, on Zomato. Everything is based on this latitude and longitude. He has your latitude and longitude, you have his latitude and longitude, his or her latitude or longitude. Then you can see him where he's standing, and he can see you where you are standing. That's your location, which is represented as latitude and longitude. Again, this is a typical Google screenshot of a Google map. Here you can see there is some buildings, and there are some monuments also. You can see there is a lat long mention at the top here, which is 42.3744 and minus 71.1. This is basically representing the Howard Memorial Church. So for your organization also, for your house also, there will be a lat long. That's the thing which we can see. We can on a map also. And Google Map is not a new thing for anyone listening to this. So that is also nothing but a combination of GIS information. Google Map is also a combination of GIS information. The same thing here you can see, this is the earth has been divided into latitudes and longitudes, and the longitude lines are showing in the red color while the latitude lines are showing in black color. So you can see the entire earth, you can have a latitude and longitude, and that will give you the reference point of your position. This also, here you can also see information is linked with features on the map and stored in tabular form. So when you have location, means you have a point for that. Where you are standing, where you are standing now, I am sitting now, it has a location. But this location has some information also apart from the latitude, longitude. What information I have? For example, I am sitting in a place and I have a latitude, longitude, but I also have a name for this position. For example, I am standing on Arera Hills or Shamla Hills, or this is this is a colony or an office, and there will be some height of this position. I am standing. What there will be some mean sea level height for this position, which is called elevation. Height or depth, both are possible. So it will have some height and depth. It will have a district name. It will have a tehsil block name, village name, ward number name, and many other things. For example, it will have a forest area, or it will have a river and canal near to me, or any information. So this point where I'm standing now can be linked with many other information, which is basically present at this particular point or present around this particular point where I'm standing. So in short, it will become the attribute of this point, which is called as attribute information. For any point which you create on GIS will have some sort of information attached to it, which is called as tabular information or attribute information. So going to the next point, what we learn to learn now, like we will have a geographic reference to our position, which is latitude and longitude, and that latitude and longitude will have some local or attribute information attached to that for that particular point. So it will have it may have so many information, and that depends on the user which information the user is interested to link with that latitude or longitude or to the location. For example, this point in the left side, there is an island here which is named as Honolulu, and you can see it is showing the age of the island. That is showing its short form, its population. It may give its elevation information and many other things also. So that will give a overall idea about that point information, which is basically named as Honolulu in a administrative way, or in a common way, or in a general way. Again, here you can see GIS. What as we talked about, like GIS is about hardware, software, and data manipulation, where we use different methodology and people and management to do certain analysis. And this analysis may be in the right side. You can say typical examples of different GIS layers which we have and which we integrated to make a real world, which what I was talking about. Like for any information, you will have several information. Like for some application, it will have customer information, street information, parcels information, elevation information, land use information. And if you will merge all of them, it will have a graphical representation of the real world for that particular area. So in short, we will have information, we will have hardware and software, we will have data and people and computer system to combinedly work as a geographical information system. And we are doing very many exercises using this GIS tool. And some common exercises are like extraction, overlay, proximity analysis, statistical analysis, and many more. So it will have data file and database. Finally, which will combine the entire process, and it will be called as GIS. So as I said, data formats. So now it comes, what are the data formats, or what are the fundamental GIS data types? So here you can see a GIS will have a data format called vector. GIS will have a data format called raster. Vector is again divided into three parts: point, line, and polygons. Whereas raster is divided into just a single next step part, which is called a pixel. Now to understand this, we'll start with a raster. Raster means pixels. Many of you must be aware of the word pixels, especially in the form of megapixel in your cameras on mobile phones, or photos, or TVs, or mobiles, whatever. Pixel means basically the picture element. Pixel is a short form of picture element, and picture element is basically the smallest unit of a picture is called pixel. It might be in a form of digital pixels in your mobile phone, the small boxes, or a pixel on your photograph, hard copy photograph or digital photograph. When you zoom any image on your computer, mobile, or even in the real world, or in the real world means in the hard copy, you will see after a certain zoom level, you will see small boxes. Those boxes are nothing but the pixels. And in the term of megapixels, the term is basically why we are using megapixel in that means how many pixels are present in a particular image. That depends upon the megapixel of the camera. But anyways, we'll not go to that. So raster is basically pixels, means anything which is in the pixel form, that is called raster, which is a kind of GIS data type. Now coming to the vector. What is vector? Vector means anything which is composed of or made of points, lines, and polygons are basically vector. Now, what are points, line, and polygons could be? How we understand this? Raster we got like any image or computer screen or digital photo. If the smallest unit as a box is basically pixel. But what is vector and what is point, line, polygons? So in GIS, vector data is divided into three parts. Points means anything which gives the information of that particular location. The thing I was talking about, like where you are standing is your point. That is basically the smallest unit of vector, or the simplest definition of vector. That is your point information. If you have point, that is your vector data in point information, and it will have only one location information in it. Means it will have, if you have a standing somewhere, it will have some point information, and location information meant it will have a geographical location in latitude and longitude. But if you have 2 points and you connect those 2 points, it will become a line. And if you have multiple points, 3, 4, 500, 1,000, lakhs, 100, millions, billions, if you will connect, or not even not connect also, but if there is a connection between those points and connectivity with line with those points, it will become polygon. So single point is point, 2 points are lines. If you connect 2 points, it become line, for example road. And if you connect multiple point, it becomes polygon. For example, any area like water body or settlement or cricket ground, whatever is there is an area is called polygons. And these are spatial features, and it will have some tabular information around, attached to this vector. So, and in pixel, you will have some pixel value for that area. It, apart from the latitude, longitude, you will have a pixel number for that area, 10, 20, 100, 200. That will be the pixel number for that area. Okay. So it is clear now. Like in GIS, the basic data format is two types, raster and vector. Raster is pixel, and vector will have point and 2 points connected lines, and multi-point connected is basically polygon, and both will have information or attribute attached to it. Now, as what I said about points, lines, and polygon, the same thing is here. In the left box, you can see points basically are representing here the cities. The points means Bhopal will have a point, Indore will have a point, Riva will have a point information. So that point will say this is the center point of the city. So that point here in the example also, point is representing the cities. So point a pair of x and y coordinates. X and y means latitude and longitude coordinates. Line means a series of points connected together, as I told earlier. And polygon means a line enclosed from end to end. Okay, so if it is a single point, it's a point information. If there are multiple points connected, not enclosed. Enclosed means not closed, are basically roads, and the typical example is road. And if it is a multiple points connected and closed, are basically polygons. So these are three example of what line, point, line, and polygons are. Again, here you can see attributes tables stores from the geographic information system. This is typical example of US cities, and this is in the above in this side image. You can see this is the intersect lines representing the roads in the city, in the state, and the polygons as enclosed polygons represents the state names or the states in the US. And there will be again information attached to this. For example, about the cities, about its heights, about its population, about its zip code, about its speed limit. For example, a certain road will have a certain speed limit. A highway will have a higher speed limit. A state highway or the district highway will have a lower speed limit, and so on. So the idea of showing this slide to you to understand, like, these point, line, and polygons will have certain information attached to it, which can be anything. I mean, there is no limit for that. You can attach hundreds of thousands of attribute information, point on information, or line information, or polygon information to any point, line, and polygon. And if we talk about the raster representation of the feature, so with reference to point, I assume that you have now got the idea what is point information. So in the left side, you can see this is point information, and the right side is the raster representation of that point. So again, as I said earlier, rasters are basically the pixels. So these square shape boxes are nothing but your raster data. So the same points which are here can be also represented on a raster data format. Okay, so this will look like this. Again, for line, this is the line feature of some road or something, and same feature is represented in the raster format here. Now the pixels are connected to form a line. Here points are connected to form a line. This is the basic difference. And for an area, which is basically the enclosed polygon, is again the polygon features here, where points are connected and closed to form a polygon. Here also pixels are clusters of pixels, a group of pixels are connected to form an area. So this is the typical representation of point, line, and polygon as vector file, which is in the left side, and as raster file, which is in the right side. Again, the same thing, each pixel will have some value, as I said, 10, 20, whatever pixel information we are storing in that area, or it's coming for that area. And if the raster on the right, and then you can see these are the typical raster maps, and that can be formed, that is also available in any maps we create, that is also raster data. And this one is from the Google Earth, that showing this Spain, which is also basically a map of raster data format. So in short, the satellite images what we are seeing on our Google map or any map which basically represents the satellite view of the Earth, is basically the raster data, not a vector data. This is again a typical example of GIS data use. And I was listening also to someone who was talking about elevation and DEM. So this is basically an example of DEM, digital elevation model. So here you can see like a digital elevation model has been created using the raster information from satellite image. And here you can see the elevation and depth also in the same image. In the right side, the blue area is basically some water body, which is you can say the depth information or the MSL information, mean sea level information. And in the left side, you can see some high areas, which is basically the elevated hilly areas. So this can also be presented using GIS. And this particular image is created using the SRTM data, which is Shuttle Radar Topographic Mission data, which was a USGS operation and like 15 years ago, where they created the DEM information for the entire world, or you can say 80% of the world. And the data is available in the public domain for free use. And the link is given here in the below. So again, the file, the vector and the raster formats. The vector formats are like a collection of files with .shp, .shx, dbf, prf, prj extensions. These particular shapefile format is basically a proprietary of ArcGIS company, which is ESRI company, ESRI company. So whenever you are working with ESRI software, you will get your output in the form of shape files, which is a very common file format in GIS world. So the shape file format is having different other combined formats called SHX, DBF, PRJ. DBF stands for database file, and PRJ stands for projection file. So it's a combination of different files which makes the shape file for a vector data set. And also there is a file format called .kml, and KMZ also is there. So these are basically the Google Earth file format. The concept is the same. This is a combination of point, line, and polygon, but the extensions or the format names are different. So it will be shapefile, .kml, and this .gdb is basically a geo database file of ESRI again. So if you are excuse me, if we are storing any information in the form of the GDB, it will have it is basically ESRI database. ESRI means ArcGIS database, and there are many others. And for raster database data formats, basically TIFF is the most popular data format, but there are others like .jpg, which is a very common RGB data format, and .ggw, .png, .img, and there are others like ESRI grade BIL. Okay, so that depends upon the what software you are using and what in which format you want to store and create your data in vector or raster format. So these are some popular data formats. So in basically vector in general, which you can say like vector is used to represent discrete feature that do not completely cover the earth surface, like road, trees, and building etc. So it's a in general. Why it's saying in general means it's not definite, but when we say in our local language, na, कि आम तौर पे, so this is basically in general. You can say like wherever there is a line like road, or where you are representing tree or building, where data is discrete. Discrete means undivided, small in species, is basically the vector data set. And in raster is used to represent broad and continuous features that cover the entire earth surface, like elevation data, precipitation data, temperature data. The data is continuous. There is no gap. If there is a gap also, it will have a pixel value for that, which is maybe not useful, but it will have a pixel value. So you cannot create discrete data or a thematic or uncontinuous data for that in raster. So now we learn up to here, we learn two things: data formats in vector in GIS, which is vector and raster, and we also learn like their utility and all. Now, can we combine these two? Yes, we can combine these two data set. So for example, if you can see in the left side, there is a red color polygon, reddish polygon basically. It's showing digital, it's basically a digital elevation model. And in the middle, it's a watershed in green color, streams in blue color, and water bodies in cyan color. Okay. So we have, for example, just an example, we have 4 set of data, and out of 4, one is raster, which is the digital elevation, and we have watershed, stream, and water bodies are vector data set. So if we combine this, it will become like this. This is from the same area. If you can see the shape of these areas, so basically these are collected from the same area, and I overlaid all 4 information, and I got a map of that area like this. Now earlier it was earlier it was data in different format and different places, so it was not giving a meaningful information. But now I combined the data into on a single map, so now you can extract the information from it, so it's now more meaningful. That is the charm, and that is the basically utility of GIS. Now when you have data from different format, different extension, different structure, and if you can combine those data on a single map, on a single place, you can extract information. Now you can see that water body is having different channels coming out of it. From here, it is also showing like these areas is highly elevated, the red maroon areas, and these areas are low elevated. So it must be water is flowing from this side to this side, or this side to this side, and it's coming to the water body here, and again from this water body it is going to the rivers in the lowland areas or to the other places. So now what we can do, we can now calculate the total, and in a word you can say this is a watershed. Okay. So now you can calculate the total watershed of this particular area. Now you can calculate how many rivers are coming from this watershed, what is the total area of the watershed, how much water is there in the watershed, also you can calculate what is the elevation difference in that area, and so many other things you can calculate, or information you can extract from this map. This can be done using a GIS tool or a software. So up to here it was so up to here when we talked about like basic things. Now these kind of analysis is basically called as overlay, but if it is more complex, we call it models. Okay. So there are different types of models present in GIS. Some are conceptual models, mathematical models, data models, spatial data models, computerized models. So based on your use, based on your utility, your specialization, your department. For example, if you are working in water related field, you can have water related analysis. If you are working in for civil engineering, you can have civil engineering related queries. If you are working for, say for example, forest or agriculture, whatever is your specialization and use, you can extract information based on the different models present in this in GIS. So this is I will not go in detail in this, so because I have to cover other points also. But this is basically when you combine different layers and different methods, it becomes a model, and that gives you a predefined output, or you can say there are the inputs are predefined and outputs may vary. So basically that is called as models. And here again, in the initial lecture session time, I was hearing about the somebody was talking about QGIS, and Madam was telling about QGIS, difference between QGIS and ArcGIS. What is the utility? So these are some open source GIS tools and platforms like PostGIS, GIS, MySQL. These are open source DBMS, database management files. And there is GRASS as a software. There's a GIDAL is a library or is a software again. There's a Quantum GIS, which is QGIS is a software, and many others. So the idea of showing this slide to you is like we have we learn about so many GIS formats, files, formats, analysis, and other thing. But to do this, we need these kind of tools. We need a database tool. We need a processing tool. We need a conversion tool. We need a display tool or analysis tool. So there are so many softwares available and tools available for to do this. Some most of the most some few of the most popular I have popular one I have shown here, but there are many others. And the quantum GIS is basically the QGIS, and ArcGIS are two of the most popular software being used in GIS industry. And again, the same again the difference is the same, which was earlier mentioned by Madam. Like it will have the QGIS is basically it's an open source, and ArcGIS is not open source. And one or two biggest differences are like QGIS, as it is open source, it's evolving also very fast. I mean, every 2 or 3 days there are some new tools are getting integrated in this, because it's open source. So somebody is developing some tool or some new tool or some new program, they are integrating it to that QGIS. And ArcGIS is basically it's also developing. It's also very dynamic, but as it is purchasable, you have to purchase the new license and you will get the updated version for that. So QGIS is definitely the best with respect to analysis, with respect to options, and many other things. Though ArcGIS is also not bad, but as it is free and very dynamic compared to ArcGIS, so Quantum GIS and QGIS is basically you can go for this. Now these are the GIS applications. So in GIS applications, you can see there is a box in the center which says GIS applications, and there are applications connected to it. For example, you can do GPS and surveying of data using GIS. You can digitizing the digitization from maps or photos using GIS. You can download data in GIS. You can add CAD input and conversions in GIS. You can add tabular data and information to GIS, coincident data in GIS, and image data also in GIS. And those inputs combinedly will give you digital informations in the form of maps and tabular information. So this is the overall picture of a GIS application, where you get data and inputs from different sources and in a different format, and many other different formats, not only one or two mentioned here, but many other formats, and that will give you the information in digital format as a map or tabular information. Now I want to focus two things here, and you can see there are two boxes marked here. What are these boxes? One is GPS and surveying data. Another is image data, right? So GPS and surveying data and image data, why I have marked it especially because apart from many other data inputs in GIS, these are the two major data inputs or data input formats in GIS. Okay, so we will see what are these data formats and how we can integrate these data formats in GIS. Okay, so you must be knowing about like GPS. Nobody is unaware of GPS these days, which is basically a global positioning system. and which is being vastly used in almost every field in this time. Rather, it is transportation, it is civil engineering, it is mechanical field, it is forestry, agriculture, water resource, many other things. Wherever we need location information, whenever we need information of the Earth or reference point of the Earth as information, for information, we need GPS. And surveying and data is one of the very common GPS related tool. And another is images. Images here, why I have mentioned images here. Images means any image in any information in GIS format which is having location information in it can be used in GIS. Okay, so coming to the next point. So these all the these data inputs can be divided into broadly into two categories. One is primary data inputs and other is secondary data inputs. Okay, so primary data is data that you collect. Very simple example, and in the form of a questionnaire key to an address, or a GPS coordinates, or a survey data, or photograph. So whatever data you collect by yourself, where you are directly involved in collecting data, is basically the primary data. Questionnaire means you ask questions to a particular person or system. You get information from that. That is basically your that is also your data, primary data. You have GPS in your hand, in your mobile phone, in your vehicle, and you that there are some coordinates attached to that information. Is basically your GPS coordinate information. Now survey data, as you know, like you go to survey and you collect data. That is again the survey data. And photographs either from your mobile phone or camera phone or satellite image. That we will see how we define this term photographs in detail. Okay, and secondary data is obtained from any other source which is not you, is basically the secondary data. So here I have mentioned so many data formats. So you can see the how digital data or the GIS data can be created. So you can see here there is the tab like thing, which is basically a digitization table, which is basically being used not popularly these days but earlier, which was being used to create maps using a digital pencil or pen on it. So it will trace the hard copy maps or the paper maps into digital maps. Same thing can be done using a computer. So here on screen digitization or heads up digitization, you call it in another way. Here you can see, like in your computer there are maps that you can digitize using a particular software, which is also called as Geo Referencing in GIS term. Can be done using a computer system. So these are manual versus computer based digitization processes. There are surveys also, as I mentioned earlier. Here in the left side, somebody is surveying the land or for some purpose. That is also a kind of data inputs for GIS. And in the right side, there's a person who is basically holding a Trimble company GPS. And you can see he's noting down something on the map. This is also a kind of GPS based survey or GPS data collection. So the next thing is the photographs. What are these photographs? What I was talking about. So till now you have seen, like, there are several ways for data inputs in GIS, survey, GPS and all. But the major data input these days, current days, is in GIS is basically the remote sensing based data. So if you want to know about GIS, and if you don't know about remote sensing, So half of your GIS knowledge is basically is only done. If you don't know about remote sensing, then you basically only know about half of the GIS, or even less than that, because a major huge chunk of GIS information is coming from remote sensing information. And what is this remote sensing information? Remote sensing information means information collected remotely for any earthly object. Or if you go by definition, it is basically remote sensing is the process of sensing and measuring objects from a distance without physical contact with them. Okay. So in the photograph, you can see there is a sun in the left upper corner, which is the primary source of energy for the satellite. There is a satellite in the right upper corner, and it is reflecting, it is basically propagating uh, information, or EMR, electromagnetic radiation, and it is going to the object, and object is reflecting back to the satellite, and it is receiving in somewhere and giving it to your computer. So it's basically a process where there is a satellite which is basically capturing the information reflected from the earth, and the information or the radiation or the energy which is coming from the sun is getting reflected to satellite images, and satellite images is storing those information in the form of digital numbers and reflecting back to the ground-based stations. And from those ground-based stations, this is the ground-based station, or the receivers, these ground-based information is again converting that information into a readable format, and finally giving it to you in your computers or mobile phones or any other processing devices. So this is a typical diagram how remote sensing system, or remote sensing or satellite remote sensing system works. Okay. So sensing may be of scanning, characterizing, classification, identification, and quantification and analysis. This is the different parts of remote sensing or the sensing system. Again, I will not go again in very much detail about remote sensing, but just for an overview, again, the definition is the remote sensing is the science of acquiring information. Here you can see there is a red color circle, and there is an object to be sensed. It's saying sensor is basically reflecting electromagnetic radiation, EMRs, to the object, and the reflected EMRs are getting captured to the sensor, and and giving us the information. This information may be in the form of 2 dimensional, which is 2D, or 3 dimensional, which is 3D. Okay. So this is again the overall process how remote sensing works. This is the sun, this is the earth objects, it's getting reflected. Some of the energies are getting absorbed also in the cloud, some are not going to the sensor. And again, these are platforms. I mean, this sensor which I was talking about can be mounted on a spaceborne balloon, or on an aircraft, or on a helicopter, or on a car, or on a satellite. So whatever it is there, use is there. Scientists are, or the companies are, or the NASA, ISRO, basically they are putting those sensors in these kind of vehicles. So these vehicles are basically called as the platforms. So if it is this sensor is mounted or placed on a satellite, it will be called as satellite remote sensing. If it is mounted on an aircraft, it will be called aerial photograph. If it is mounted on a balloon, it is also called an aerial photograph. It is mounted on a car, it will be called as a ground-based platform. Okay. Again, this is a decision-making thing. This is very complex, so I will not go into that. But the overall idea is, like, you have satellite, you will get information that will be converted into some digital number or digital data, and data that will be converted finally to a information, which is basically nothing but information about the earth. Here you can see, like, spatially distributed entities. Areas are series of they again the same thing. In satellite image or this remote sensing also, you can map areas, which is basically in the form of polygon. If there is an image and there is a lake, if you make a box of that image, in a GIS software, that box will be, or that polygon will be called as polygon area, or area, where you can calculate the area information also, and similar for the other point and line information. Again, this is the some kind of repetition of the earlier slide, why we use remote sensing and all. So I'm skipping this also. And again, remote sensing can be broadly divided into two types. Remote sensing means sensing from the remote sensor mounted on satellite or balloon or aircraft. One is called active remote sensing, and another one is called passive remote sensing. By mistake, it is written two times active remote sensing. It's a tapping mistake. But one is active remote sensing, another is passive remote sensing. Active remote sensing means a passive remote sensing. First, we will understand whatever when the source of energy is sun, and the sensor which is mounted on satellite or somewhere, if it is dependent on some other source of other source for radiation or information or for sensor radiation, it will be called as passive remote sensing. And in this, major source of information is basically the passive major source of radiation is basically the sun. And so it means if there is no sun, this particular this type of satellite will not give you the observations or the information, right? So because it is depend on the sun. To minimize or to reduce this problem, there are some active sensors also. Active sensors are not dependent on sun or any secondary source of data source, but it creates its own sense radiation in the form of pulses or light. So what are these active sensors? Active sensors are basically the radars are the active sensor, the lidar, light detection and ranging are the sensors where the light is coming directly from the satellite and it's going to the object and reflecting back to the sensor. So it is not dependent on sun. As it is not dependent on sun, it can work in nighttime also, or probably in a bad weather also, where there are some clouds and other information, other hindrance there in the atmosphere. So again, active and passive, and whatever I said is summarized here. Like in active remote sensing, the energy source is artificial, created by the sensor. And examples are SLR and SAR, synthetic aperture radar and side-looking airborne radar. And passive sensors are nothing but when the energy source is natural, most of the time it is sun. And the sensors are called the Landsat sensors and spot sensors. These are basically the name of some satellite and sensors, most popular. And satellite-based information will give you the global coverage of that. If you have satellite, you can get data for the entire globe in a period of for 2 to 3 days time. These satellites are basically designed for 3 years or 5 years of time, and the uses are also varied from defense to civil and many others. And these sensors, which is satellite based, are basically used to scan and transmit information in the form of radars and other information. It gives you wide and synoptic view. This is the most important part of satellite based sensors compared to balloon or aerial photograph. In satellite based sensors, as it is mounted so high in the sky, maybe more than 500 kilometers or 800 kilometers above the land surface, so it can see the entire world in a single view, and it will give the photo of the entire world, not the entire world, but at least 30% or 20% of the earth in a single view. So for a synoptic view or a complete view of the earth, it will take 3 to 4 days, and it will give a compile information of the entire earth for in 3 or 4 photographs or satellite images. So there are some other information like about the scale factor, the repeated coverage. Repeated coverage means if the satellite is taking a photograph of Bhopal city today, after how many days it will come again, because it has to cover the entire globe, entire earth. So it will be coming back to Bhopal again. So it will be coming to Bhopal again, maybe after 2 days or 3 days or 15 days or 20 days. That is called the repetitive coverage of that particular satellite. Low spatial resolution, as it is very high in the sky, its spatial resolution or the pixel size or the ability to differentiate two objects is very low. And actually this is also, as it is giving you a synoptic view or very broad view of the object, it is very cost effective also. Again, the applications of remote sensing can be in meteorology, in oceanography, in glaciology, in geology, agriculture, hydrology, disaster control, and many other. Okay. And global positioning system, again, this is basically this slide is should be in the earlier, but it is saying like GPS was developed by US Department and still maintained by DoD. So here we are talking again about the second major source of data input in GIS after remote sensing. The second major input is GPS based inputs. So GPS was basically, as is mentioned here, it was initially developed by US Department, USDA, DF, for military use, and still it is being maintained and operated by US agency also. So in short, the data, the information of location information you are getting on your mobile phone or Swiggy or whatever Google Map is basically dependent upon the GPS, which is in control in the control of US Department Defense System. So again, can they switch off their satellite image, or can they manipulate the data and location information to fool other countries? Is it possible? Yes, it is very much possible. That's why several countries has now have their own GPS systems or satellite system where they can use their satellite system for their country. India is one of the countries, one of the very few countries in the world. We also have our GPS system or the satellite system where we can get location of for any area on our for our region or our subcontinent region using the satellite information. But still we are using the global positioning system or the US system. In combination we are getting the information. If we are using different data from different countries, or the global GPS data from different countries, it is called as GNSS. And if we are using only data from the US Department of Satellites, which is called as GPS. Okay. So again, one more thing which is not mentioned here, I just want to let you know that as it is used by US Department of Defense, they have two broad modes of output. One mode of output they are using for their military purpose. Output means the GPS accuracy. They have using the same GPS satellites. They have a very good ground accuracy, which they are using for US military. And the public use accuracy is the output what we are using is having some sort of inaccuracy. Means if you are saying like I am standing in this place and this is this latitude and longitude, but in real world this is not exactly the latitude and longitude, but shifted 5 to 10 meters in any side of you, I mean around you. So that is not that accurate. So 10 15 meter deviation is always there. But now we have several other technologies which we integrate with GPS. For example, we have a technology called VAS, we have a technology called CORES. So using these, incorporating these technologies with the GPS, now we are in a position of getting information, accuracy information even up to a millimeter or not millimeter, centimeter level or below 1 meter level. So this issue, we are not now we are not completely dependent upon the US Department to get information of accuracy or get in GPS information. Okay. So again, this is navigation in your car, finding your favorite fishing hole, mapping trails or roads. These are all depend upon the GPS. And as I said, as you know also, like GPS is satellite-based radio positioning system designed, financed, deployed, and operated by US. Here, why we go for GPS? What are the major, charms of GPS. What is the charm of using GPS? There are some points like the relatively high positioning accuracies from tens to meters down to the millimeter level, the capacity of determining velocity and time to an accuracy commensurate with position. The signals are available to users anywhere on the globe, in the air or ground or sea. Means the ships, the sea ships or the navigation ships are also using GPS. The aeroplanes are also using GPS. The trains are also using GPS. The cars and bikes are also using GPS. So there's a wide use of GPS. It's all weather working. It is, if there is storm also, if there is cloud also, it will, that data will be available 24 hours a day without any gap, without any uh, and you know without any gap or without any differences. It is will be available for the entire globe for 24 into 7. So there are three segments of a GPS system. Segments means there are three components. Combining these three will basically create the GPS segment. So first one is the space segment. Space segment means the satellites which are basically in orbit in the space, which is revolving around our Earth in 24 around 24 hours. This is called the space segment. The control segment are basically the ground facilities carrying out to task satellite tracking, orbit computation, telemetry, supervision necessary. The ground-based people who are basically maintaining and controlling the satellites, the GPS satellites, and the user segment, the entire spectrum of the application, equipment, and computational techniques that are available to the users. So there is a satellite based in the space. There is not one satellite, but there is a combination of satellites. In US-based system, there are 24 satellites, plus 3 also in buffer, and there is a control segment based majorly in the US, but also in part of the world. And there are user means you and I and all are users. So there are three segments which complete the GPS segment in total. Same thing, you can here can see space means satellite which is spaced, and user are we, and control centers are the towers on the ground. If you see the space segment, I will go to all the segments one by one, but the most important is the space segment. Here you can see the space segment consists of the constellation of spacecraft and signals broadcast by them, which allow users to determine position, velocity, and time. The basic function of satellites are to receive and store the data transmitted by the control segment stations. So I will show you one. Rather than showing you this text, I will show you. This one. This I wanted to show you first to make your understanding about GPS. So here you can see in the center there is our Earth, the Mother Earth, and you can see there are so many satellites revolving around it, right? These are basically a graphical representation how GPS system works. You can see there are so many satellites, and if you will count this will be around 24. So these satellites are designed in a way in the orbit by the scientists of US, like in any position for any time for any position any time, there will be at least 3 satellites available for that reason. For example, if you are standing here, you will get signals from these 3 or these 4 satellites. If you are standing here, you can get signals from these 3 satellites or these 3 satellites. So as they are evolving, they are changing its position also, but you will be at least able to see, or at least able to get information from at least 3 satellites for that particular point. Why 3 satellites? Because based on that 3 satellites position only, you will get your latitude and longitude and elevation information for that point. So at least 3 satellites is required. If there are only 2 satellites available, which is not possible, you will not get the information. But if there are 3 satellites available for your area, in your area, then you will get your GPS working. And more than 3 will increase your accuracy. If it is 4, your accuracy will further improve. If it is 5, 6, 7, 8, 9, 10, it will improve further. In my experience, I have seen 11 satellites in my GPS receiver showing for that area, which was giving me the position accuracy of up to 3.5 meter or 4 meter. That is my experience. So this is a typical representation of the how these satellites are working. So going back to the previous satellites, then again we'll come to this. This space segment, as I said, receiver. This it has like receive and store and data transmitted by the control segment station. It maintains the accurate time by means of several onboard atomic clocks. So basically, it's saying that the clock mounted on the satellite is basically atomic clock, not like any quartz clock or the clock we are using at our homes or offices. So again, this is the same thing where they have the ground control stations distributed all over the world. Here you can see like very closest to India is in Bahrain. There is a ground control point in Bahrain, and in South Korea there is one point which look close to India, but there are some other points, and most of the points are you can see is in this region, which is basically the North America, or you can say America. So most of the points are in America, but other points are also distributed all over the world, including Australia, New Zealand, Tahiti, Argentina, and other. And this is again divided into master stations, which is only one in the Colorado, US, and ground antennas, Air Force antennas, and NGS stations and all. We don't have to go too much into this. These are the user segment after space and ground. This is the user segment. User segment is basically the user where we can receive the information in our devices, either a GPS device or DGPS device. DGPS is differential GPS. So here you can see in the left side there is a mobile phone in someone's hand, which is also giving the map and GPS information. This is a typical Garmin GPS. Here you can see the lat longs also in that particular region for particular area, and it is showing the speed and bearing and many other information. Here also this is a GPS device again showing the lat long information in it. So these are the user segment. In the user segment, again, as I said, if you have 3 or more satellites available, you will get the latitude, longitude, and elevation, velocity, etc. for that particular area. And based on these 3-4 combinations, you do all the work. And these data is basically going into the system and stored as a point information, line information, polygon information, which basically finally being used in a GIS to do many work. So it gives you the navigation and the timing that is already as I told you earlier. So again, this is the little bit more about the satellite constellation and all. For example, it is at an altitude of approximately 20,000 kilometer. There are 24 satellites functioning that I mentioned also, and it is also saying like in a fair day, in a good day, you can have 6 to 10 satellites visible most of the time for a particular region. And there are many other information like how much time it is taking, what is the to make a one revolve, and all these things are information are there, which is not very important. So we'll go to the next slide. This is again saying satellites are deployed in 6 orbital planes of 60 degrees, and many other information is there. So again, this is covered, but not very important in the fundamental of remote sensing or fundamental of GIS talk or presentation. And this one already I have shown you that how it works. And this is the GPS devices, and the two major GPS utilities are navigation and surveying, which again I discussed. And surveying includes the GPS can be used for surveying in the process of locating points on the surface on the earth, and GPS can be used in baseline measurement for geodetic survey, stalking out, and many other forms of survey. GPS is also very useful for layout work, for locating boundaries. Overall, this equipment is fast and accurate. So it's the major 2 point surveying and navigation is again divided or described in a better way. Here you can see typical examples of surveying. These two photographs you can see. They are using a differential GPS. Differential GPS is basically nothing but an advanced form of GPS, where it uses differential information to more accurately uh, collect the location information. And again, these are the some application areas for GIS. For example, it can be used in hydrology or cadastral map, agriculture, environment, geoscience, forestry, emergency services, public services, navigation, and urban town planning, oil spilling, disaster, and many other. I mean, as I mentioned in the earlier slides also, like these GIS applications are increasing day by day, and now it is in almost all the fields where you can think. I mean, where there is location information is required. Again, civil engineering applications you can see here, like transportation, watershed analysis, environmental impact analysis, remote sensing based information capturing, urban development, target site selection, landfill site selection, mineral mapping, pollution mapping monitoring, natural hazard assessment, resource management, and many more. I mean, there is no end point for this, where you can. It's all up to you. Means if you know the concept, if you have the software ability, how to use the data and how to manipulate the data, it's up to you how you want to utilize this. Uh, Utilize the GIS, combining GPS and satellite information. So this up to you. And people are coming day by day. People are coming with very new and innovative ways of using GIS and GPS utilities for many purposes, including few of them mentioned here in this slide. Again, for urban planning, output in the form of map showing areas in which land use change or more likely to occur, and statistics, graph, tables summarizing this information according to a variety of specified spatial units, such as such outputs allows land use applications to be discussed. The predicted land use changes can also form input of GIS based. Means if this is something is here in 10 years, it will be something else. The land use may change to some other form. So that can also be done. In urban mining process also, you can say like quantification of stocks, localization of stocks, collection, separation. All these things can be done using the GIS and GPS remote sensing based data. Most probably with you had the help of digital elevation or 3D data. Digital elevation, when I'm saying, means I'm talking about the 3D data where that information is also there. And last two slides, probably the most important slides. The what are the job? So these are some organizations which are basically working nationally and internationally in GIS and GIS related fields. Like ISPRS is there, IGARS is there, NASA is there, ESA is there, which is in Europe, NASDA is there. These are some international organizations. And in India, there is an organization called NRSA, National Remote Sensing Agency, which is based in Hyderabad. So there are other organization and fields where you can have a job, and you can get a job if you have good knowledge of remote sensing, if you have good knowledge of GPS, and combinedly if you have a good knowledge of GIS. So there are centers like Regional Remote Sensing Center, RRSCs, Space Applications, SAC, and there are private companies also like Rolta, RMS, Reliance. There are many oil sectors like Shell, Indian Oil, mining. There are private government organizations like state mining agencies or state governments, universities. There are organizations who's working in crop insurance. There are organizations like forest department, agriculture, and etc., where you can get a where you can look for a job, and you can or you can work with them. If you are already having a job, you can work with them or collaborate with them if you have understanding of GIS. And these are some slides and links for these organizations, and where jobs prospects are there. So finally, this is my final slide, and you can see this is a one of the oldest map of the world. And here you can say earlier how people were thinking, how the earlier explorers were thinking how the earth looks like. So this is one of the maps. So this is all about the presentation. I think I have still 14 minutes left before 12. So I will be happy if there are any questions or clarification is required. One thing I also want to mention, this GIS is very vast, very vast and very broad field, and it's almost impossible to cover all the points and clear all the points in a session of 1.5 hours. Even one day or 1 week is not sufficient. There are so many other things like projection system, like what are the universe coordinate systems. These are what is geodesy, what is many other things are there which we can cover to understand GIS, which I have not covered today. But of course, there are so many things that we can see and learn. But the today's presentation was mostly on the fundamentals, formats, file formats in GIS, and what are the data inputs. So if you want to really interested in GIS, you can contact me, or you can directly go to the internet and learn more about GIS. There are organizations also in India which gives you 3 months, 6 months, 1 year GIS course. Like there is the most popular and best organization in Dehradun, IIRS, Indian Institute of Remote Sensing. They are also running courses for teachers, faculty members, scientists, and organization heads, and for students in their organization.
Thank you very much, sir, for a very insightful session on GIS fundamentals. In a very short period of time, you explained like very difficult terms, I must say. But you have explained in a very simple way, and I'm sure that the concepts must be started getting clear. I think and I wish as a course will progress and we will actually work on the various tools of GIS, these fundamentals will get more clear. And so it was a wonderful presentation by you. I think most of the participants, they must be willing to interact with sir. So can we hear from any doubts or anything to ask?
If there is no question, I assume I have not able to make a single point clear to you, or maybe
No,
you
no,
have
no.
you have cleared all your points.
Yeah, it's opposite. Yes, sir. Yes, sir. Actually, you have explained in a very interesting and very with very like all my concepts got clear, sir.
Okay,
Like
thank you.
I'm not an expert in this field, but I'm very curious to know much more about the tools. Okay. Any questions from participants?
Yes, ma'am. Actually, sir, it was a very insightful presentation, and we learned a lot through this. Shall I know how to download or where we can get the data sets, sir?
Yeah, of course, Meena Kumari ji.
Yes.
If you down, if first, if you, as you said, where to download data. So first you have to decide which data you want to download. Again, the same thing. You want to download vector data or raster data. In vector or raster also, are you interested in downloading satellite data or some other data? So if you are interested in downloading satellite data, there are several satellites which are providing free of cost satellite data. One of them is basically Landsat satellite, which is from 72 onwards. Data is available 1972 onwards. From that you can download data, and there is one very good satellite recently launched in early 2000. It is Sentinel Satellites, owned by European Space Agency. So they are also giving you satellite data for up to 10 meters spatial resolution that also you can download. And for vector data, like for example, road data or river data, water body data, there are several organizations which are providing data for in a vector format also. One of the most popular is Map My India website. If you will go to the Map My India website, you will get data for most of the major major layers for India, for example, water or state boundary or district boundary. And again, if you are interested in downloading digital elevation data, the SRTM is there, AICTE is there. There you can also download, and of course from Bhuvan also, which is basically Indian Space ISRO's data archive. There also you can download free of cost data from their website up to certain limit.
Thank you so much, sir. Thank you so much.
Sir, you told about like remote sensing and GIS. Both are very important, and knowledge of both is equally important. So, what type of information or what type of knowledge about remote sensing is required for as far as GIS analysis is concerned?
Madam, I'll rather say again, as I said, like this is a very vast field, and from agriculture to forest to civil engineering there are many fields where you can use remote sensing for in GIS environment. So if your data, if your need is, I mean, if your analysis is related to something, you can look for that for data related to that. For example, for civil engineering related work, the most important remote sensing data is elevation data, digital elevation data. So you can get digital elevation data from many sources. You can create also digital elevation data. In Indian scenario, we have Cartosat series of satellite information for digital elevation models and digital elevation data. And from other countries, there is a satellite called there was a mission called SRTM, and that is also very good and most popular digital elevation data people are using. So SRTM and AICTE and Cartosat, these are the digital elevation data that can be used for civil engineering related works. And there are other satellite information like Landsat is also there. LIS is the one satellite, linear imaging self-scanning, which is Indian satellite, that is also can be used to create land use land cover. So in short, that depends on your utility. If you want to do land use land cover, you use optical data. If you want to do some disaster related analysis, you can go for a microwave satellite data. And if you are doing some elevation related analysis, and you can use for digital elevation or a combination of all these three.
Okay, thank you, sir. Any query from participants? Okay, so there are some limitations of these online courses also. So if you feel like asking any question, you can ask later on also. Like you can mail us and we'll try to satisfy your query. Okay, so thank you very much, sir, for taking out time for this training program on movie in a very short term notice. So we are very much thankful to you, sir. And sir, we look forward to more sessions from your side.
Sure.
Thank you very much, sir.
Thank you.
Thank you, sir. Okay, we'll start this second session, and let me check. Just give me 1 minute. We are very happy that Dr. Katyar sir is with us. So let me, sir, please allow us to welcome you, sir, on this.
Thank you for
Yes,
inviting me.
thank you so much, sir, for accepting our invitation, sir. And so let me, sir, give a brief bio about you, sir. Professor Dr. S.K. Katyar, he is presently professor in Department of Civil Engineering at Maulana Azad College of National Institute of Technology, Bhopal. And her broad areas, subject area is civil engineering, and field of specialization is geoinformatics, remote sensing, GIS and GPS, survey and geodesy. He has done his BTech from Kanpur University, MTech from IIT Kanpur, and PhD from IIT Kanpur. And then he joined MANET on August 94 as lecturer, and he's presently working as I said, professor in civil engineering department. He's worked with Rolta India Limited Bombay as product executive, GIS and mapping. And he also worked as senior project associate at IIT Kanpur for about 8 months during 91 to 92 for different research and consultancy projects. And his exposure to the state-of-art techniques in surveying and working on the modern techniques of mapping, like total station, laser level, remote sensing, global positioning system, and geographic information system. And the PhD project was also, it was funded by Indian Space Research Organization, ISRO. And during this program, worked on use of latest technologies like DGPS for the geometric rectification of remotely sensed images, experience on the use of industry standard softwares like ArcGIS 9, ARDAS, Imagine, etc. And he completed many consultancy projects also sponsored by Ministry of Defense, Government of India, and for different cantonments of Madhya Pradesh and UP. Okay, and Adding something more about his achievements, he published 50 research papers in national and international conferences and journals, worked for different research and consultancy projects for the reputed organizations like ISRO, Ministry of Defense, etc. He was Dean Research and Consultancy in Manet, and then also HOD Civil Engineering Department from 18 to 19. He was coordinator Center of Excellence in Geoinformatics under TechWip 2 project also. Chairperson, he is chairperson Council of Wardens. Life membership of following society he is having. That is Indian Society of Geomatics, Space Application Center, Ahmedabad, Indian Society of Remote Sensing, IIRS Campus, Dehradun, Indian Society of Technical Education, IIT Campus, New Delhi, and also Indian Institution of Engineers, India. So, sir, very interesting bio brief, and we are delighted to have you as an expert in our training program. So, sir, once again, welcome you, sir, and please take the charge of the session, sir.
Okay. Are you able to hear me?
Yes, sir.
Good afternoon. So, thank you, madam, for inviting me and giving introduction. First off, I would like to tell you that material for participants after lecture I will provide you. Just I was busy with my classes, 2 classes since 10 o'clock. So that is one thing. I want to know that what is happening in remote sensing GIS. That repetition. So when you started this course, means which day is there?
Today's first day, sir.
This is the first day.
Yes,
okay.
Sir.
So
We just had
only
sir, we just had a lecture on fundamentals of GIS.
Okay. So I will try to, because my topic is on application in GIS, but directly jumping on applications that may be difficult for some participants, because first we should understand the technology, then in better way we can understand. So initial 10-15 minutes I will take for the background, because in most of the cases people get confused in GIS. So in the lectures I will make it clear what is the confusion. And another thing is that I want this session to be interactive one. So in between I will ask so that we can go, because in 1.5 hour lecture everything cannot be delivered. So I will probe. So I want to know about participants. All are teachers and the students also are field persons.
Yeah,
so what is the
Ji. So mostly the participants are from educational institutes. Academicians are majority of them are academicians, and some are industry persons, and a few percentage of research scholars, sir.
Okay.
Basically, they all are from field of architecture and civil engineering. Most of them are from.
So are you able to see my PPT slide?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So the topic of talk is GIS applications in civil engineering. So I have added that geoinformatics. So I hope that most of you may be aware about geoinformatics. So we can understand it with the help of this slide. I think slide has changed.
Yes, sir.
So if we talk about geoinformatics, it is also known as geomatics engineering. IIT Kanpur and Manet and NIT Allahabad, these 3 places they are using geoinformatics. At IIT Roorkee, they are using geomatics. Both have similar meaning. So geoinformatics is something more than the GIS. Now sometimes confusion starts that I am not expert of surveying, I am expert of GIS, I am expert of remote sensing, I am expert of photogrammetry. So this is the skeleton on which we are sitting. So if you want to use GIS, you cannot do it in isolation. So in brief, I will give you idea. Surveying is basically, it is a technique of collecting data on the ground and which is represented in the form of map. Now there are different techniques. If you remember that earlier in advanced surveying, people used to study the photogrammetry. Photogrammetry is very old technique. Now global positioning system, GPS, that has come in the year 2000. Now remote sensing is also a data collection technique which is being used since long time. So photogrammetry is also remote sensing, but nowadays, because of developments in satellite technology, remote sensing is a separate thing. Why it is separate? Because we have multiple type of data. For example, in photogrammetry, you can collect the information in the visual range. You may have laser, this infrared photogrammetry also, LIDAR technology. So remote sensing covers microwave, laser data. Now there is a lot of data. Earlier, what we were doing, we were collecting the data with the help of total station instrument or theodolite, digital theodolite. And we were doing the task with the help of EDM, we were doing it. Now there is plenty of data available for a user. So this terminology GIS has come into picture because you have a lot of data in your hands. How to analyze it? So this gave birth to GIS. So you can call it a sink in which everything is there. So basically it is a computer-based system in which we give input to every data. Now this we have downloaded from somewhere, our students. So you are seeing that this cartography has got bottom hierarchy. But I am telling you that without this cartography knowledge, you cannot handle the GIS system. So in earlier lecture, Dr. Sandeep Goyal might have told you about GIS, but there are few things which are very important and not very complicated. But because of ignorance, we don't understand it. So this is the definition of GIS. A computer-based information system that enables data acquisition, modeling, manipulation, analysis, presentation, and dissemination of spatially referenced data. Now it has got so many things, spatially referenced. So anybody can tell what is the meaning of this spatially referenced data? What is spatial data? No idea? Okay. So we talk about pillars of GIS. Then these are the 5 pillars. And these 2 bottom pillars are very important. Means you require methodology. you require knowledge, people from different fields, people are working on it. Now these three things anybody can have. There is no dearth of this nowadays. Now GIS has reached to such a stage that you require one good laptop computer. Remaining things will be taken care by open source. Means there was a time that people were searching satellite image. Now you can freely download. So a lot of changes are there. But we should understand that nobody can claim that that person is a expert of GIS, means they know everything, because that is not possible. In GIS, different field people are using for different purposes. So I will highlight few points, then we will go to application, that what are the applications possible. So in a layman language, if you consider that what is the GIS, so basically this may be image, this may be a photograph, then you convert it in a form of map in the digital form, then GIS comes. So I think you have one lecture on the fundamental concepts of GIS. Any participant can tell what is difference between AutoCAD and GIS software. Yes? No idea?
Sir, AutoCAD is drafting software, and GIS is, I guess, it's more of a information modeling, something related to the geographical inputs.
Can you introduce your faculty or a student or sub-field engineer?
Sir, I am a research student currently.
Where?
So I'm just applying for it.
Okay. So
Yeah.
what do you mean by drafting?
Drafting, like we say, AutoCAD is computer-aided drafting.
Okay. Then what do you understand from drafting?
Drafting means...
that is not done in GIS?
Sir, I don't know exactly about the GIS. I'm just giving a guesswork sort of thing.
Okay. Anybody else? So at this stage, you should understand that in GIS, you have got AutoCAD or 3D map plus all the functionalities which you can do related to maps, you can do in GIS also. But there are certain things which are not possible in a CAD software. In CAD, not only AutoCAD, there are CATIA or so many softwares. Now, when we are talking about GIS, then we have got few questions that whether we can do it. So in the beginning, I told you that spatial data, geospatial technology. GIS is also known as geospatial technology. Geo means Earth. If you see in AutoCAD, you will see that they will write the Beluch. This distance is this one, this distance is this much. If you will write coordinate, then you have to write. If in drawing it is not there, then you cannot get. That is not true in GIS. It is already geo-referenced. Geo-referenced means some coordinate system will be attached to it. As you will click, you will get coordinates at any place. If you want to measure distances, you can do it. This is done with the help of one thing that is known as geo-referencing. Geo-referencing is not done in AutoCAD or any CAD software. So another thing is attribute. Now, how to do geo-referencing, that is not my topic of talk, but I want to tell you that georeferencing is one of the difficult thing for the beginners, where they get confused and they take anything like what is datum, what is projection. So all these things, and normally people don't talk. So do you have any idea about this map projection and coordinate system datum? Yes, any idea? So if you don't have knowledge of all this, then GIS will be a toy in your hands. खिलौना समझते हो ना बच्चे, खिलौना वो गन होती है, उससे कट कट आवाज होती है, बस और कुछ नहीं होगा. You cannot do any analysis if you don't have knowledge of this coordinate system. So that is base here in GIS. Otherwise, there are 4 entities: point, line, area, text. Now, what is special in GIS? Why people are using? I think when we are discussing about applications of GIS, then there is no corner untouched where GIS is not used. Even if you go for political parties, in election you see different type of distribution in constitution based on different, say, caste, religion. They do various type of analysis. All this is GIS platform. In the COVID situation, containment zones, distribution of red, yellow, pink areas, all this is GIS skeleton. So beauty of GIS is that it has communication with the graphics and attribute or table. Means you have got this table displayed. Say for Assam state, we are interested in finding different statistics for all states. So when you will click the Assam, this is total India information is there in this table. As you will click, different information in different columns will be available. You can add 100 of column. There is no limit. So what is happening? Suppose nowadays web-based GIS is being used by so many organizations. Say in infrastructure. Nowadays, around 2-3 years back, we got one letter that they want to do online monitoring of the progress of construction projects. Then we have got this Geo Tagging. Once one of our student came that they want to do Geo Tagging. Means suppose अभी जो गवर्नमेंट की स्कीम्स चल रही है, एक टॉयलेट्स बनाने की स्कीम जो है, so they will not do the payment until unless you send it geotagged image. Anybody has idea about geotagged image? Yes. Geotag.
Image with location data in it.
Okay.
So that we can identify. Yeah.
How you can have a geotag image with your mobile phone?
Sir, we can do the location on and we can click the image and geotagging is done automatically.
Have you seen how to see the coordinates?
Yes, sir. I have various applications for that. In my phone, I can click on that or on the Google location and I can redirect to the location where the photo was taken.
So in mobile, you can have a geotag photo. If you go to, have a photography hobby, if you go for purchasing the camera, there will be written that this camera is can give you geotag image. So basically, GPS chip is fitted in that. You can get your location. So because of that, GIS is very popular that now everything is coming on GIS skeleton. They are doing online monitoring of the construction progress with the help of satellite images and location you can get in GIS environment. So there is communication between graphics and attribute information. Now another importance of GIS is that we have layered information. Means in GIS, those who have worked, some of you may be familiar with the GIS software. So when we have got shape file, you have got different shape files for different features. You can superimpose one on another. So you can have analysis of that data. Means you have data in the form of shape files. You can analyze it by using different themes, that is known as thematic data. So basically it is a thematic information. For example, for some area we have different parameters, say lakes, then soil type, geology, DM, different layers you can superimpose and you can find out resulting information. Just अभी हमारा लेक्चर चल रहा है, ये लोग फील्ड में है, थोड़ी देर रुकता हो तो आफ्टरनून में आ सकते हैं, मैं वेट कर लेता हूँ, ठीक, नीचे बैठ कर. So this is all about GIS. Now I will not go in GPS, but I will tell you a few points. That GPS is one of the technology which is running the GIS. If you don't have any coordinates, you cannot imagine about GIS. So GPS is one of the source for GIS. Now there are three segments. I will not go in detail of that because that is maybe a separate lecture. Most of you may have used GPS. How many of you have used GPS instrument? Anybody? Nobody has used GPS instrument, not mobile. GPS instrument. Anybody knows how to convert your mobile phone into GPS instrument? No idea?
No, sir.
Huh? Actually, recently in June, we did one training for CAPT, Central Academy of Police Training Institute, that is in Bhopal. So he was very happy and again told that you help me. So technology is there. You can convert your mobile phone into GPS instrument by using some apps. So that is not topic of talk today, but the topic of talk is that which GPS you should use, because there are different type of GPS. GPS is a brand name. Otherwise, it is known as GNSS, Global Navigation Satellite System. Why this specific name? Because GNSS is generic name, GPS is American system. We have got GLONASS, we have got Galileo, European Union, we have got BIDAO from China. Then India has also got IRNSS. So a lot of activities are going on in the field of GPS, but people are ignorant about the instrument which is to be used. So when you are using it for GIS, be careful if your accuracy requirement is there. You can put this is the simple antenna. But DGPS and GPS are two terminology. Anybody knows difference between GPS and DGPS survey? GPS survey and DGPS survey. No idea?
We know that GPS is nothing but global positioning system, and we don't know,
Yes.
sir, DGPS.
DGPS you don't know. Okay.
Yes, sir. Yes.
So what is happening? Most of the projects are spoiled. Those who are working in government department, when they float the tender, they write GPS survey. Then companies cheat them. In GPS survey, you cannot get height value very accurately. GPS survey means with one receiver you derive the information. So that will have some errors. So your accuracy in XY plane will be between 5 to 10 meters. And in height values, you may have variability 1.5 times of that. Means 8 to 12 meter error will be there. So don't use for contouring. बहुत सारे लोग जो है सिंगल रिसीवर से बोल रहे हैं कि हमने जीपीएस सर्वे करके कंटूरिंग कर दी. So don't remember, this is the slide which is showing how GPS is collecting the data. So I will not go in detail. This is the point positioning, means GPS survey with single receiver you collect the information, but it has got different error. So we have got differential GPS, differential global positioning system means we apply correction to the collected data because a GPS signal has got a lot of errors. Those requires to be corrected. So this can be done. Errors can be eliminated. This is the simple process. Nowadays, RTK survey is more popular. तो जो भी GIS का वर्क ज्यादातर आर्किटेक्ट्स है, तो आप लोग कंटूर मैप और ये सब टोपोग्राफिक मैपिंग तो चाहिए होती है. So you should ask for DGPS survey and RTK survey can solve your problem. RTK DGPS survey. We should ask for not only GPS survey. Now in remote sensing, I think Dr. Sandeep Goel may have touched some aspects. I will not go in much detail. With the help of some images, I would like to tell you that how these can be helpful for us. So this is the system, different components, definition, we be knowing. Now we can collect data from different altitude. So nowadays, remote sensing technology has reached to such a level that we can have very good amount of data. So I want to emphasize with the help of this slide that most of the cases people say that I have done my PhD using remote sensing GIS for this and that. If you ask them what is GPS satellite, what is a remote sensing satellite, they are zero. So don't get confused with the remote sensing and GPS satellite. So anybody can tell what is the difference between the GPS and remote sensing satellite? No idea? Remote sensing satellites are polar satellites, sun-synchronous satellite. These are at low altitude, 500 to 800 kilometer orbital altitude. But GPS satellite are at 24,000 kilometer altitude. These are semi-geostationary orbits. Geostationary orbits, you may be knowing. If it completes one rotation of Earth, it is stationary with respect to Earth. Now for GIS input, nowadays you can have stereo images. Indian satellite is also Cartosat is providing that data, but I don't know what is the position. I tried, but not very much happy. So this bird view, quick word, they are having a stereo imaging capability. You can get height information in the range of around 1 meter accuracy. So if we talk about applications, then different applications require different type of images. So this is the image of Bhopal lake. Bhopal city is also included in that. So you can see here that this is a different type images. Now, if your objective is to find out just outside periphery of that how much area is covered with lake, different layers, then you can use this data. This is the list 3 image. So with the help of this slide, I want to tell you that there are so many sensors. When you go for the application, first you should clear that what you want to analyze. Because nowadays in remote sensing, there is no dearth of information content. You can have 0.3 meter resolution data. But for most of the purposes, specifically if we talk about planning purposes, I don't think that you require high resolution data. So Indian satellite lists 4 multispectral images more than sufficient. So what people say that I have purchased a bird view image for the planning. Okay, you can have, but you are increasing your problems because data volume is also increasing. So depending on your requirement, what is your requirement? You want to do land use mapping. If land use mapping, at what scale? So this is the 5.8 meter monochromatic image of TT Nagar Stadium. This is Iconos image, Saeed Smarak, quick word, some more images. So with this, we can enter into applications that we have got 4 things in GIS which we should remember. One is spatial resolution, another is spectral resolution, third one is temporal resolution, fourth one is radiometric resolution, and scale. So if we talk about GIS, directly radiometric, spectral and temporal are not related, but spatial resolution and scale, these are very important. Anybody can tell what is scale? Any idea? नहीं पढ़ा होगा ये तो, अगर जो आप लोग आर्किटेक्चर से भी हैं तो स्केल तो लेते होंगे ना. एनीवे यू कैन रीड, देयर आर बुक्स, सर्वेइंग की बुक में भी दिया होगा. नाउ पॉइंट इज पीपल डोंट अंडरस्टैंड व्हाट इज द मीनिंग ऑफ स्केल. सो इन जीआईएस देयर इज नो स्केल. आप देखेंगे जीआईएस में कहीं भी ये नहीं होगा कि ये स्केल सिलेक्ट कर लिया है. जीआईएस इज स्केल फ्री data. Because of that, every organization is using, because there is no loss of information. Suppose you draw a map on scale 1:50,000. So many details will not be there. For example, in Bhopal Municipal Corporation, if you are drawing some bird map on 50,000 scale, then you cannot draw the trenches, say, वो जो wastewater drain line और मेन होल्स, क्योंकि उनको आप पॉइंट में भी नहीं रख पाएंगे. सो दैट इज वैलिड इन केस ऑफ स्पेशियल रेजोल्यूशन. आई विल नॉट गो इन मच डिटेल ऑफ दैट. इन एप्लीकेशंस आई विल ट्राई टू मेक यू फेमिलियर विद दैट. सो दिस इज वन ऑफ द माय PhD student. He did analysis, used stereo satellite image. So it's Manit campus, then adjoining hills. So you can superimpose the image on the DM and you can get data. So this SRTM and Aster, these are the very popular. Nowadays, this LiDAR technology is very much upcoming technology. By using LiDAR technology, you can get height information also. So this is the ultimate technology, and you can use this as a reliable and very accurate input in GIS. So with this much overview of this technology, I will switch to second slide. If you have a specific queries, you can ask. Otherwise, I will move to next one. Just a minute. Yes, slide is visible.
Yeah. Yes, sir.
So when we talk about applications, we cannot talk applications in isolation for GIS. If we are talking about GIS, it is understood that remote sensing will be there, GPS will be there, because these are the input for the GIS data analysis. So we can have agriculture, forestry, geology. There are so many applications. It is not possible to talk. If anybody want to have understanding of it, there are so many books. One book is about lily sand and kefir, but few specific applications. Say if we become specific for civil engineering, then this land cover and land use mapping, it is equally important for the architects also in planning, not only planning for the sitting projects, whether these are water resources projects or urban development projects or in agriculture. We have got input for it. Otherwise, there are n number of applications there. So if we go for the mapping, say, if you want to create a GIS database, that is the very first step. Few examples I want to tell you. These are the information which are required. What is land use? What is geology? What is forest cover? What is soil type? What is habitation? There are water bodies. There are slopes. There are crops. All these informations are required. Now, if we see that what is the source, you will find from literature also personal information, Survey of India, topo sheet, field work also. But nowadays in GIS environment, you can do these things very easily in a reliable way. So in most of the cases, we come across with different issues. Now these issues are accuracy, then data on time, cost effectiveness, then reliability, latest and up-to-date information, old data requirement all of a sudden, trend manpower requirement, security concern, and legal aspects. Now, these are the few things which I have identified that these are relevant for any application of GIS, whether you talk about civil engineering or administration. If we talk about accuracy, if your map is not accurate, it will not sit at its place. Easily in GIS, you can identify data on time in GIS environment. You can extract this data from multiple sources. For example, if you are interested in finding a slope of some area, then easily you can have DM. डीएम कहाँ से डाउनलोड कर सकते, किसी को आइडिया है? यस, no idea. So Bhuvan is one of the site, ISRO. Then you can have USGS, SRTM, Aster. These are the two popular DM. You can collect it, and I am sure that if you carry out that work by some surveyors की लेबलिंग करानी है, तो शायद उसमें गड़बड़ी हो सकती है कि इस डेटा में गड़बड़ी नहीं हो. There are some other agencies also which provide you data, so you can use open source data. Cost effective, no cost is involved. Open source data is available. Reliability, there is no question of reliability because it is taken by satellite, no human intervention, so that data is available. Latest and up to date. You see, this USGS, they are putting Landsat images after 1 week, 1 to 2 week time they put on the web. You can download.
Hello, sir.
Yes.
Hello, sir. Sorry for interrupt, sir.
Yeah.
We can only download digital elevation model file or other format also available. You know, when I was downloading this DAM file from Bhuvan site, so Bhuvan only allow me for 16 tiles, 16 tile in a day. So is there any method to download more tiles, or means we should download only DAM file, or other file format will also support for this analysis purpose?
You are field engineer or some faculty?
Architecture. I did VR.
You are architect?
Yeah, I am architect.
Actually, problem is that you have lack of information. Otherwise, I don't use Bhuvan only. Bhuvan का I am not very happy with their data. लेकिन ठीक है, हमारे इसरो के एजेंसी they are improving day by day. Otherwise, और बहुत सारी you can note down that Aster or SRTM. इनका डेटा जो है ज्यादा एक्यूरेट होगा, रिलायबल होगा. अब ये कहाँ से लेते हैं? इनका कार्टोसेट जो सेंसर है, कार्टोसेट 2 का तो स्टीरियो इमेज मिला, बाकी ये कहाँ से क्या करते हैं. और 16 टाइम्स का है, तो यू कैन यूज दैट USGS वेबसाइट.
USGS.
हाँ, अब तो गूगल पे जो है
explore this website and download few tiles and do analysis on particular things. So because I face some problem in this Bhuvan, so I'm just sharing with you.
नहीं, एक्चुअली क्या है कि हमारे इंडिया में क्या प्रॉब्लम है कि पहले तो लोग बताते नहीं पूरी इंफॉर्मेशन. वो सोचते मेरे पास रहेगी तो मेरी इम्पोर्टेंस बढ़ेगी. That is. Another, I am also academicians, but I am not happy that delivery from से कोई कोर्स भी होता है, अब उस कोर्स का ऑर्गेनाइजेशन ये होता है जब जो पकड़ में आ गया उसका लेक्चर करवा दिया. तो दैट इज द प्रॉब्लम. अदरवाइज जो है ये सारी चीजें तो बहुत रिलीवेंट है. मतलब हम लोग एक स्टूडेंट से मैं थीसिस करा रहा हूँ. ही हैज आइडेंटिफाइड अराउंड 15 वेबसाइट from where you can freely download DM from different satellites. अभी तो बहुत changes हो गए हैं. There are so many, not only Aster and SRTM. So I will suggest you that on Google you put just download of DM, satellite DM. You will go to that site and so
in earlier lecture, sir said you can download from Map My India. So Map My India still means developing site. I explored it, but it's like
okay. I don't recommend such type of people. Map My India fellow, he earn a lot of money and पेपर में भी उसका एड देखते होगे. वो जो चिप है $1 की आती है GPS की, वो यहाँ फिट करके जो है बेचता है 10,000 रुपए में. ठीक है. Once he called me for having employment of some students. So he told he will give 12,000 rupees. I told that 12,000 my students are getting stipend fellowship. So what it was, my India, I don't think they have credentials to do all this. This is the high tech thing. We should rely on the prestigious and reliable things. So map my India exists nowhere. अगर if he exists, he will charge money on it.
Definitely.
क्या है, चीटिंग इंडिया में बहुत है जीआईएस के नाम पे, कि उसने कोई भी चीज ओपन सोर्स से कर लिया और उसके बाद वो बेच रहा है. तो दैट इज द प्रॉब्लम. सो आई विल सजेस्ट यू, मेरा ईमेल आईडी वगैरह मैंने पीपीटी पे दिया हुआ. आई विल शेयर इन माय नोट्स. सो इफ यू हैव एनी प्रॉब्लम यू कैन कांटेक्ट मी. आई विल टेल यू. अभी तो मेरे पास से स्लाइड में बहुत सारा नहीं, सारी चीजें बता भी नहीं. मैं इसीलिए एप्लीकेशन तो ठीक है, लाल पीला मैं आपको दिखा दूं, 1.5 घंटे बाद चले जाए, यू आर हैप्पी, आई एम हैप्पी, बट यू शुड गेट समथिंग. तो इसलिए मैं ये चीजों को टच कर रहा हूँ. I will come to some case study also, which one of my PhD student did. So another thing is old data requirement all of a sudden. This is a very important thing in application and especially in administration. क्या होता है, अभी आप लैंड एक्विजिशन करते हैं, जैसे एनएचआई डिपार्टमेंट है या इरिगेशन डिपार्टमेंट है, डैम कंस्ट्रक्ट किया, सबमर्जेंस में किसान आ जाता है कि साहब मेरा तो वहां पे ट्यूबवेल था या मेरी झोपड़ी बनी हुई थी. मध्य प्रदेश में घर बनाते हैं ना खेत में, कंपनसेशन मांगने लगेगा. नो, व्हाट यू विल डू, नो व्हाट यू कैन डू, यू कैन गेट सैटेलाइट इमेज इन जीआईएस एनवायरनमेंट. उसकी पोजीशन होगी पूरी, एंड इवन कोर्ट्स आर आल्सो एक्सेप्टिंग दैट. हम लोगों ने मतलब इट इज मैटर ऑफ ईयर 2006 जबलपुर का प्रोजेक्ट किया था. हाई कोर्ट की इंस्ट्रक्शन थी, तो वहां पे जबलपुर म्यूनिसिपल कारपोरेशन ने बीएसएनएल की बाउंड्री तोड़ डाली थी पूरे. अब वो डिस्प्यूट था, थर्ड पार्टी से करवाना था. तो वी डिड विद द हेल्प ऑफ जीपीएस सर्वे देन सुपर इम्पोज्ड ऑन सैटेलाइट इमेज. तो ओल्ड डेटा से आप कर सकते हैं. तो दिस इज द बिग थिंग विच यू कैन डू इन जीआईएस. A lot of encroachments are there. We did projects for total मध्य प्रदेश. ये डिफेंस की बहुत सारी जमीन इंक्रोचमेंट थी, अभी भी वो उलझे हुए हैं. अब वो मैंने जो बताया वो समझ नहीं रहे हैं, बट इंक्रोचमेंट रिलेटेड इशूज यू कैन रिजॉल्व. आई विल शो 1 or 2 slides from that also. So in that high resolution image or temporal data can be helpful. Trained manpower required, that is a big problem. क्योंकि हम लोग अभी मान लीजिए टोटल स्टेशन खरीद लेते हैं, लेकिन वो उसको चलाने वाला वो ढूंढते हैं, वो अगर जो सही नहीं है, डेटा कहाँ कलेक्ट किया, क्या किया हुआ है. बट इन जीआईएस यू कैन हैव डीजीपीएस सर्वे. आजकल हो रहा है सब जगह. यू डायरेक्टली इंपोर्ट दैट इन जीआईएस एनवायरनमेंट, प्लॉट करके. अगर जो कोई एरर्स होंगी तो रेक्टिफाई. एंड अनदर थिंग इज दैट यू रिक्वायर सम इंटेलिजेंट पर्सन्स इन योर चैन, नॉट ऑल. से जीपीएस सर्वे करना है, उनको बता दिया भाई ये बटन दबाना है, डेटा कलेक्ट होना, बाकी प्रोसेसिंग आप कर सकते हो. सो दैट इज बिग एडवांटेज. अनदर इज सिक्योरिटी कंसर्न्स. लैंड एक्विजिशन में बहुत होता है. आप गांव में कहीं जाओगे और ऑर्डिनरी इंस्ट्रूमेंट लेके अगर जो वहाँ सर्वे करोगे, तो देर में भी थ्रेट टू लाइफ एल्सो. अभी ये माइनिंग वगैरह में तो गवर्नमेंट के आईपीएस वगैरह भी कई लोगों पे अटैक हुआ. सो दिस यू कैन डू विद द हेल्प ऑफ सैटेलाइट इमेजेस. मेरे पास मतलब ये 7-8 साल पहले ये बार्क के लोग जो है, देयर इज वन एजेंसी, न्यूक्लियर पावर कॉर्पोरेशन ऑफ इंडिया, एनपीसीआई. दे अप्रोच्ड मी, टोल्ड दैट हाउ टू टेक केयर. वो वहाँ पे एक छुटका डैम है जबलपुर के पास में. So they want to establish some nuclear power plant. तो वहाँ वो लोग, गांव के लोग अपोज कर रहे थे, ट्राइबल्स भी थे कुछ, तो they were not able to occupy that. So these are the few things where our GIS can help. Legal aspect, all the maps which you produce in GIS, these are legally accepted. ये geospatial शायद AICTE भी पास किया है गवर्नमेंट ने. So now some of the issues are accessibility, weather, integration of data, compilation of different team data, data sharing. So all these things become easy if you have your data in GIS environment. So applications I will tell, but a few points I have identified where we can have use of GIS, geoinformatics technology very well. So I will suggest you, if you have notebook, you please note down. I will.
I'm writing.
नहीं, इसको लिख लीजिए. इन द मीन टाइम एक्चुअली हमारा एक इंस्ट्रूमेंट डाउन है, कंपनी वाला आया हुआ है दिल्ली से. मैं उसको बोल दूं कि अभी थोड़ा वेट कर ले, या किसी को बोलता हूँ. So after 2-3 minutes I will be online. In the meantime you note down this. यहाँ खुली है. नहीं, ये क्या ऊपर लैब खुली है तो उसको देखो, एक बैटरी तो 100% चार्ज लगी हुई है, लैब खुली है। मैं एक लेक्चर के बाद ज्वाइन करता हूँ, खुले हैं वहाँ पे। बाकी उससे कहते स्टूडेंट्स को बुलवा लेना, वो फील्ड से आ जाए। ठीक है, हाँ, ऊपर लैब में चला है। ठीक। So I hope that you must have written all these points. These are small things, but a big task. We did one PhD irrigation department on river meandering, and aspect was that in Kanpur barrage they wanted to do reclamation of land for developing the residential area there. So in that they validated, so I will not go in detail of that, but these things, and finally we came to data sharing and RTI. So that is the final thing which we require. कभी कोई बोलता हमको ये डेटा चाहिए, वो डेटा चाहिए। अभी मैप कॉस्ट और मैप आईटी में भी बड़ा टसल चलता रहता है। तो इसमें ये है कि you can share the data with your password. So these are the potential areas in which GIS is helpful, but it is not possible to discuss each component. So I will be a bit specific that how we can do it. So if we go for the present scenario, then there are few things which are coming in a big way. One is the GPR technology. Now this GPR technology, anybody is aware about GPR instrument? नाम सुना है किसी ने? आवाज आ रही है मेरी?
No sir, no sir.
आवाज नहीं आ रही?
Yeah, no sir. We are
आवाज आ
listening
रही
your
है?
sound.
आवाज आ रही है ना? हाँ, तो you don't know about GPR instrument?
No sir.
So what is happening that in cities you will find out कि कभी टेलीफोन लाइन की केबल किसी ने काट डाली, कभी पाइपलाइन फोड़ दी। हमारे कैंपस में भी खूब होता था पहले, अभी बहुत दिन से नहीं है, बिकॉज वी डोंट हैव एनी टाइप ऑफ मैप्स फॉर दैट। सो दिस इज वन ऑफ द एप्लीकेशन। इसमें एकेडमिक फील्ड में भी वर्क कर सकते हैं। ये जीपीआर इंस्ट्रूमेंट आता है डिफरेंट रेंजेस का। यू कैन डायरेक्टली import your GPR data-based images of all the utility lines in GIS environment and put on the web. So this is one of the application which is required. अभी दिल्ली वगैरह में शुरुआत की हुई है, मेट्रो वगैरह में उन्होंने सीखा। बहुत सारी जगह प्रॉब्लम हुई, जब अंडरग्राउंड जा रहे थे तो बहुत कुछ परेशानी हुई। तो देयर वाज वन ऑफ माय एमटेक स्टूडेंट, वो मेट्रो में था, तो उसने फिर मेरे को फोन किया, हालांकि वो जानते होंगे। देन आई टोल्ड हिम व्हाटएवर नॉलेज आई वाज हैविंग। देन रिमोट मॉनिटरिंग ऑफ इंपॉर्टेंट स्ट्रक्चर्स लाइक ब्रिजेज यूजिंग जीपीएस टेक्नोलॉजी। ये थोड़ा सा मतलब इट हैज गॉट जीआईएस स्केलेटन। क्या होता है, अभी जब स्पिलवे से पानी छोड़ा जाता है तो वाइब्रेशंस होते हैं ब्रिज में। सो देयर इज ए डैम मॉनिटरिंग सिस्टम which you can have in GIS environment. GPS instrument लगाते हैं, तो that is another application. Third one is unmanned aerial vehicle or drone based mapping for geo intelligence. आजकल एक खूब यूज हो रहा है, लोग अपने शादी वगैरह या फंक्शन वगैरह में भी यूज करते हैं। So now government has also allowed some grade of UAV for public use. एडमिनिस्ट्रेशन पुलिस डिपार्टमेंट यूज करता. So geo intelligence is one of the term which is used, and specifically for land encroachment. Land encroachment बहुत बड़ी problem है सारे cities में. So for the architect, planners, civil engineers, it is a big problem. So you can create the buffer by finding the encroachments. I will show some slides how it can be done. Another is planning and management of smart city infrastructure like vehicle tracking, intelligent transportation system, telecom tower, safe location. On this, one of my PhD student, Prashant Parsai, did PhD for a smart city. So I will show you his case study. Then another is property tax assessment inventory using high resolution satellite images. ये एक ऐसा एरिया है कि इसमें तो करोड़ों का बिजनेस है. But what is happening that private players are working on that, but they are not getting proper results. Reason is lack of knowledge. वो लोग जिन लोगों को अपॉइंट करते हैं, उनके काम करने वाले लोग, उनको पूरी नॉलेज नहीं होती है, तो बहुत ज्यादा नहीं. अदरवाइज ईच म्यूनिसिपल कॉर्पोरेशन इज डूइंग दिस. नॉट म्यूनिसिपल कॉर्पोरेशन, छोटे छोटे जो नगर पालिका, वो लोग भी सब कर रहे हैं प्रॉपर्टी टैक्स असेसमेंट. इससे हाई रेजोल्यूशन सैटेलाइट इमेज एंड इन जीआईएस डेटाबेस. तो सब जगह जो है जीआईएस बेस्ड, इसलिए आर्किटेक्ट्स भी जो है सारे जीआईएस सीखना चाहते हैं, क्योंकि आज की डेट में प्लानिंग हमारी जो है बिना जीआईएस के नहीं हो सकती, क्योंकि हमको बहुत सारे पैरामीटर्स लेने पड़ते हैं. वही पॉपुलेशन डेंसिटी कहाँ, किस डायरेक्शन में ग्रोथ हो रहा है. फॉर मास्टर प्लान वी आर यूजिंग इट. So property tax assessment inventory, that is another area. Land encroachment. India में we were the first academic institute who did highest number of consultancy for land encroachment to this Ministry of Defense. मेरे पास कानपुर तक का काम आ गया था, फिर भी मैं झांसी लेना पड़ा. तो मऊ, पचमढ़ी, जबलपुर आधा कैंटोनमेंट है. We did it. That was GIS database creation to find out encroachments using satellite image and GPS. That was a wonderful experience for us also. हमारे सारे MTech students गए थे. And most of the cases they worked for that. हमने कोई मैन पावर नहीं अपॉइंट. Multi-storied buildings and high-rise tower verticality and machine excel alignments. ये थोड़ा स्पेसिफिक हो जाता है एप्लीकेशन, नॉट रिलेटेड टू जीआईएस. So if we talk about application, suppose landslide prone areas, you can find out by open source DM. You can generate the drainage, nuclear based site planning. You can have different parameters. One of my PhD student done research work, impact of coal mining on environment. So you can see that by putting data in GIS environment with the cartosat image, easily you can find out how was a soil. So 3D view. So this dumping, you can find out in GIS. So 3D view generated from Raster satellite data DM of 2009. पुराना वर्क है. तो ये पिट्स जो माइंड एरिया है, तो इलीगल माइनिंग you can identify. This is another image. So you can find out drainage pattern, drainage density, steam orders for land erosion and all other type of. Not only that, in GIS, this RSPM, this is a parameter for air pollution. So because of mining activity, there is pollution. So he had drawn different pollution level contours in the GIS environment. Now you can have drainage patterns in GIS by open source. So this is the land encroachment related thing. This is area for one of the cantonment. Because of security reasons, I will not tell which one is that. So a small portion I have cut. So what we did, we superimposed. This is the iconous image at 1 meter resolution, multi-spectral. They were having their maps. We superimposed that and determined that where is the encroachment. We went to ground with the GPS instrument. So that is one application. Then Survey of India topo sheet. We determine the encroachment boundary. They have got boundary pillars. You can easily do it, but this type of analysis requires solid knowledge of coordinate system. सर्वेइंग की नॉलेज आपको नहीं है तो आप ये सारे एप्लीकेशन नहीं कर सकते. मतलब मैप इधर उधर जियो रेफरेंसिंग की पूरी नॉलेज होनी, इसलिए मैंने शुरू में बोला you forget about any application if you don't have knowledge of coordinate system and map projection. So this is all about applications. We cannot end here, but we should have thought that okay, we are doing it, but knowingly or unknowingly what we are doing, and for that GIS is needed. So in the beginning, I told you that key issues in infrastructure development, I want to highlight some issues that what is happening, and mostly in this program, architects are there. So I want to ask a question and give attention for them that what is happening. This is a quite common thing that houses are flooded. In Bhopal also, this is I think 2006 flood आई थी, तो बहुत हालत खराब हो गई थी. These are the some cuttings. You see, मकान बनाए हैं, करोड़ों रुपए के मकान हैं. So कार डूब गई है, राजभवन की दीवार टूट गई थी. So these are all the newspaper clipping. मैंने कुछ नहीं बनाया हुआ है. नो अभी भोपाल से चलते हैं. बहुत सारे लोग भोपाल के होंगे. So I want to know that what is the reason for all this failure. Any idea anybody can give?
Not utilizing the natural runners channels, like because of development, they are getting affected, our natural runners system.
Okay, that is correct. Natural drainage system, they have completely damaged. Now here our architecture and civil engineering community who are involved in planning, they should have look on it that what basically we are doing. It is not a development, but it is a problem creation for the system. जिन लोगों के मकान बह गए कितना, it is happening in every city like this only. Now I want to show you case of Gurgaon. Yeah, just.
वो लॉग आउट हमने उसको लॉग आउट कर दिया था, फिर से साइन इन किया, नहीं हो रहा है.
ठीक,
मतलब उसको हटा भी दिया था टीम्स को, फिर टीम्स को लॉग इन किया, तब भी नहीं. अपना दोनों का है उसमें, तो किसी से करवा लीजिए.
तो पासवर्ड प्रोटेक्टेड है, कोई छूता नहीं सिस्टम.
किसी से करवा लीजिए, तो देख लीजिए.
Now this is one newspaper coverage. इसका आगे जो आपको देखना है, जस्ट ए मिनट, मैं आपको रियलिटी बता रहा हूँ व्हाट इज हैपनिंग इन आवर कंट्री.
कटियार सर, गुड इवनिंग सर.
गुड इवनिंग. यस
सर, आर्किटेक्ट अभिषेक आपके अंडर में पढ़ाई किया था सर MNIT में.
कब?
2007 पास आउट हूँ सर, 2003 से 7.
अच्छा, मैंने पढ़ाया था कोई सब्जेक्ट आपको का?
हाँ सर, आप लोगों को.
हाँ
SDD 2।
यस, अच्छा सिविल से किए हो ना?
नहीं आर्किटेक्चर सर, मतलब 8 में पास आउट हूँ। आपने हम लोगों को 5 में पढ़ाया था,
हो सकता
एक
10
सेमेस्टर।
में मैंने रोके। सो आई वांट टू शो, जो स्लाइड में दिखा रहा हूँ ये कोई मैं अपनी तरफ से नहीं, टाइम्स ऑफ इंडिया में एक कवरेज था, ये गुड़गांव का था। पीपल लिविंग इन द मिलेनियम सिटी स्टिल रिमेम्बर the images of cars floating in the submerged basement of luxury apartment। तो ये लोग क्या है यहाँ पे बना रहे हैं, और ये इस तरह का था। अब मेरा ये है कि if we will do like that, भाई पानी तो कहीं जाएगा ना। अब आपने बिल्डिंग बना दी, हमारे पास कोई प्लान नहीं है कि वहां का पानी कैसे हम डिस्पोज करेंगे। एक तो बिल्टअप एरिया हो गया, सीपेज नहीं हो रहा है, मतलब ग्राउंड में जो सीपेज होता था, क्योंकि सारा फ्लोर बन गया। तो दीज आर दी इशूज। अब क्या हो रहा है, हर साल नाले की सफाई, आप नाले की सफाई करोगे ठीक है, नाले की कैपेसिटी क्या है? जैसे हमारे यहाँ रिवेरा टाउन में ये पूरा नाले पे सारा बना दिया है, आपने आगे कैपेसिटी बढ़ाई क्या? तो दीज आर दी इशूज विच कैन बी एड्रेस्ड बाय द कम्युनिटी। जो स्टूडेंट्स हैं आजकल रिसर्च कर रहे हैं, आजकल रिसर्च भी बहुत अच्छी होती है कि उन्होंने लाल पीला इमेज इसका एफसीसी लैंड यूज, हमारे एमटेक स्टूडेंट भी बहुत प्रेफर करते हैं, भोपाल सिटी का लैंड यूज मैप बनाते हैं। कुछ नहीं, तो मैं चाह रहा हूँ कि कोई ऐसी रिसर्च हो जिससे कुछ एक ग्राउंड की प्रॉब्लम, तो फ्रॉम आर्किटेक्ट कम्युनिटी I want to request that they should do something with the help of GIS. A lot of things can be done. लेकिन समस्या क्या है
No,
कि
sir, we are proposing, sir, we are proposing. There are now, if you know, that CM Rai schools has been proposed. So we, for Indore segment, we have got 12 schools.
नहीं, आप क्या भोपाल म्यूनिसिपल कारपोरेशन में है क्या?
नहीं सर, मैं तो प्रैक्टिसिंग आर्किटेक्ट हूँ।
नहीं, मैं बता रहा हूँ आर्किटेक्ट की सेप्ट अहमदाबाद से कंसल्टेंसी ले रहे हैं, और बहुत पेपर में भी खूब निकलता है।
ओके।
और मैं बड़ी बात नहीं कहता हूँ, मेरे को कोई मतलब नहीं है किससे कंसल्टेंसी ले रहे हैं। एक और कंपनी है महाराष्ट्र की, वो जीआईएस बना रही है, शायद 5 करोड़ का प्रोजेक्ट दिया हुआ भोपाल म्यूनिसिपल कारपोरेशन। मिनट में कभी नहीं आएंगे वो सीखने के लिए, और मैं कुछ बोलता नहीं हूँ, मतलब ठीक है, वो तो उनका काम ही बताता होगा कि पेपर में ये भी निकलता है कि उससे कुछ नहीं हुआ। तो दैट इज द प्रॉब्लम कि हम सही डॉक्टर के पास जाना नहीं चाहते हैं, क्योंकि सर्जरी करने की जरूरत है और सर्जरी से हम डर रहे हैं, तो इसलिए ये सब हो रहा है। दैट इज द प्रॉब्लम। ये अच्छा है, तो फॉर आर्किटेक्ट्स आई एम टेलिंग दैट दे शुड यूज जीआईएस टेक्निक। तो ये आपने अपने थीसिस में केवल लाल पीला इमेज लगा के और बोल दिया यहाँ पे ये है वो है, दैट इज नॉट वेरी यूजफुल रिसर्च। तो ठीक है, मैं कोशिश करता हूँ, एक दो स्टूडेंट्स को बोला, बट दैट इज ए पेनफुल थिंग, उसमें मेहनत करनी पड़ती। तो ये स्ट्रक्चर वहां बनेगा जो ये था ना, ये भी टाइम्स ऑफ इंडिया से ही मैंने लिया हुआ है। सो दैट इज द इशू। नाउ अर्बनाइजेशन, वी आर हैविंग स्मार्ट सिटीज। So for a smart city, we have so many parameters, so many guidelines. So in that context, around 3 years back, शायद उसने 2018 में कंप्लीट किया है, डॉक्टर प्रशांत परसाई। So he did his thesis on this evaluation of a स्मार्ट सिटी एरिया, जो सिलेक्ट करने की बात हो रही थी कि हम भाई कहाँ से सिलेक्ट करें। सो दैट केस स्टडी आई विल शो यू देन। आई थिंक टाइम विल बी also over and I will stop. So just a minute. Otherwise there are so many things. So let us quickly. So this is GIS based decision support system for land use planning. So all the aspects, it is not possible to explain for me also, because so many things he did. But what he did, I want to tell you that how he did decided on the basis of some parameters that there should be a smart city and what are the parameters to be considered, then how GIS can work as a framework for that. So from different sources he collected data, Survey of India topo sheet, BMC boundary map, then electricity distribution system, telecommunication, mast location. Then he used Cartoset 1, List 4 and GeoEye digital globe images also. He divided the total Bhopal area in a 1 kilometer grid, I think. And he divided total land use in, I think, 8 categories. Land use, settlement, open space, tree canopy, park, water body. Then in infrastructure, he took different infrastructure, water supply points, road network, median, one-way rate, road traffic island, school, colleges, hospitals, substations, telecommunication. So these are the 8 different categories he named, then coding 1, 2, 3, 4, 5, 7, 8. Now on the basis of that, he did raster interpolation, Kriging technique to generate the raster maps for each category, that what is the situation. Then he superimposed each one in GIS environment. So this was the total framework which he did, and he worked on QGIS, that is the open source platform. Then I will show you results that telecom towers, what are the areas, because in news papers and TV coverage we come across that various type of hazards are there. So with the help of this buffering option in GIS, he generated. You may be knowing about buffering. Dr. Goel may have told. We can radial buffer, point buffer, line buffer, 500 meter, 200 meter, that you can draw. So these are the different towers. So buffering analysis for 100 meter range he did and generated that what are the areas which are subject, how many buildings are subjected to radiations. Then this is the geostatistical analysis for telecom mast and other parameters. So by giving different weightages to different parameters, finally he determined the final grade to find out that what are the areas. So weightage to different parameters he had given on the basis of some research papers, and there is one technique, multi-criteria technique जो ये EHP में यूज करते हैं, that he is used, and final outcome he had decided that medium, low and high priority, what is that area. Later on there was a clipping in newspaper also. I think that is there. ये बात है, ये शायद कैमरा के सामने पढ़ने में आ रहा है आप लोगों को? नहीं, न्यूज़पेपर
नहीं सर, पढ़ नहीं सकते।
नहीं आ रहा हो, साथ में भेज दूंगा। ये दैनिक भास्कर में 18 जुलाई 2016 में वो लोग आए थे, तो दे प्रिंटेड ऑन द, अच्छी कवरेज थी। लेकिन उसके बाद क्या होता है, ये तो न्यूज़पेपर में निकल जाता है, तो ग्राउंड लेवल पे हाउ मच इंफॉर्मेशन दे हैव टेकन. सो हाई प्रायोरिटी एरिया he determined, how accurate that was, that is up to the users. तो किसी ने अप्रोच तो बहुत नहीं किया कि भाई हम इस रिसर्च को यूज करें. So that is the another problem in Indian system. So this is all about a smart city. Now, quickly, I will have another slide, that is the last one. Then 5 minutes I will keep for the question answer. So in GIS, we have got two formats. Do you know raster and vector format?
Yes, sir.
So line work is vector format, and this all the images are the raster data. Then, so raster images you can have from DM. You can generate the digital surface model. So there are two models, tin and grid model. Even you can find out submergence in which direction water will flow. You can determine. Anybody knows which tool we can use? In ArcGIS, there is hydrology tool in which you can find out this flow direction, and you can find out slope also. So in GIS, you can have from this DM, you can have point data, you can have contour maps. So there are so many things to discuss, but directly the topic allotted was application. It is not possible to do the justice. So I think we are left with 5-6 minutes. So that was one-way communication. So 5 minutes for discussions. What you think? So I want from participants any queries or any discussions. If no queries, then we will stop. Yes.
Sunil sir, there is one small query. Whenever
Yeah.
we are doing hydrological study,
Yeah.
so the application that we usually use ArcGIS, it's comparatively easier, and we do the basic understanding so how the hydrology and how drainage to be provided in site and all.
Yes.
So in advanced for a city level planning, which software should we use actually? As we are not an expert of GIS, but as a novice, if you are employing some GIS expert, so what are the parameters that we should check? Are they giving us the correct information? And
now you are talking about hydrological applications or in general?
in general, means in GIS also we understand the hydrological study means for doing the
Honestly
hydrological
speaking, on
study.
a hydrology tool, I have also not done much work. But if you talk about general parameters, then one of the problem I have already told you that we should not go for wrong data. In wrong data, how you can protect it? Geo referencing. तो मैं आराधना मैडम को रिक्वेस्ट करूंगा कि जियो रेफरेंसिंग जो भी लैब सेशन करवाते हैं तो बड़ा अच्छे से सबको करवा देना, क्योंकि बहुत सारे लोग जियो रेफरेंसिंग नहीं करवाते हैं, लाल पीला वो बता के चले जाते हैं. एंड इन जियो रेफरेंसिंग एटलीस्ट दे शुड टेल फॉर हाफ एन आवर व्हाट इज कोऑर्डिनेट सिस्टम. जैसे जियो रेफरेंसिंग अभी मैं पूछता हूँ जोन नंबर कैसे पता करोगे? व्हेन यू गो टू गूगल अर्थ, बॉटम में जोन नंबर भोपाल का 43 है. अभी 43 कैसे आया? आपने भोपाल का तो 43 बता दिया. अब अगर जो कहीं जोन नंबर सिलेक्ट करना है, मान लो वो जम्मू कश्मीर में गया, देन हाउ दे विल फाइंड आउट जोन नंबर? बड़ा सिंपल है, लेकिन लोगों को नहीं पता है, छोटी छोटी चीजें नहीं मालूम है. तो दूसरा है मैप प्रोजेक्शन. तो कुछ भी एक सिलेक्ट कर लेते हैं, तो दैट शुड नॉट हैपन. व्हाट मैप प्रोजेक्शन? देन डेटम आजकल इसीलिए लोग जो है, तो आई विल सजेस्ट यू दैट डोंट गो बियॉन्ड यूटीएम एंड WGS 84. ज्यादातर लोग यही कर रहे हैं जिनको नई नॉलेज है इस सब की. तो लेकिन वो देख लो कि आपने एक में एवरेस्ट तो नहीं कर दिया. अब कभी कभी क्या करते हैं बहुत सारे लोग कि चलो कोई भी सिलेक्ट कर लो, इस बार एवरेस्ट कर लो. So when you will do such type of thing, then it will be difficult to use that data. वो बहुत सारी जगह मतलब प्रेस्टिजियस ऑर्गेनाइजेशंस ने करोड़ों रुपए उनके बर्बाद हो गए, लेकिन वो डेटा नहीं यूज कर पाए, ये मतलब पहले की बात है। तो अभी ये होता है। तो जियो रेफरेंसिंग इज वन थिंग। जियो रेफरेंसिंग जब आप प्रॉपर करेंगे, then everything will take its place. Second thing is that you should use proper coordinates. कोई भी डेटा आपने सेव फाइल बनाई है, फॉर एग्जाम्पल हैंड पंप लोकेशंस ला रहे हैं, तो वो उल्टा पुल्टा डेटा नहीं होना चाहिए, नहीं तो वो एक दूसरे के ऊपर बैठेगा। चाहे आप बार्ड मैप बना रहे हो, यही तो वह जीआईएस प्रोजेक्ट जो बीएमसी के चल रहा था, वो कहीं के कहीं हो रहा है, पेपर में निकलता रहता, क्या है आई डोंट नो। तो यू शुड हैव एक्यूरेट डेटा। उसके लिए मैं बोल रहा हूँ कि आप डीजीपीएस सर्वे करो, अगर जो आपकी एक्यूरेसी रिक्वायरमेंट बहुत अच्छा है। सो यू शुड यूज मोर एंड मोर डीजीपीएस डेटा रेदर देन जीपीएस डेटा। अब यहीं पे पता नहीं रहता वो जीपीएस सर्वे करा रहे हैं। सो दैट इज अनदर थिंग। थर्ड थिंग इज, मैं एनआरसी हैदराबाद गया था किसी प्रोजेक्ट के चक्कर में। आई वाज सरप्राइज दैट दे वर डूइंग मुजैकिंग इमेजेस की। तो वी शुड नॉट डू मुजैकिंग। क्या है, आप मुजैकिंग करके इमेज को बड़ा कर देते हो। सो व्हेन यू आर इन जीआईएस एनवायरनमेंट, व्हेन यू विल डू जियो रेफरेंसिंग, उस लेयर को क्लिक करोगे तो वो तो अपनी जगह पे बैठ जाएगी ऑटोमेटिकली। इन जीआईएस मुजैकिंग इज ऑटोमेटिक। So I think these are the few things. Last point is that you should not use always high resolution data. हमारे पास पैसा है, जैसे ये जो है अभी पेडेस्ट्रल मैपिंग में काम कर रहे हैं जबलपुर वाले, सॉरी ग्वालियर के लैंड रिकॉर्ड्स में। अब वो हाई रेजोल्यूशन, फॉर व्हाट यू आर परचेजिंग हाई रेजोल्यूशन डेटा विदाउट अंडरस्टैंडिंग। अगर जो ठीक है भाई, अगर जो किसी के लैंड पार्सल्स के लिए वो कर रहे हैं तब तो ठीक है। सो यू शुड फाइंड आउट योर एप्लीकेशन, दैट फॉर विच एप्लीकेशन यू आर डूइंग। एंड अगेन वन प्रॉब्लम इज ओपन। ये लेक्चर में मैं नहीं समझा पाऊंगा, उसके लिए मेरे को आधा घंटा टाइम चाहिए कि स्केल क्या होता है। स्केल शायद बहुत कम लोगों को मालूम है, और मैं बताता हूँ जितनी जगह मैं लेक्चर देने जाता हूँ, नोबडी कैन एक्सप्लेन द स्केल, व्हाट इज स्केल। तो दैट इज वेरी इंपॉर्टेंट। स्केल की नॉलेज होनी चाहिए, क्योंकि जीआईएस में जो है, मैंने ऐसी पुलिस रिसर्च देखी है एकेडमिक में, पता नहीं फील्ड में क्या, दे आर मेकिंग 1:20,000 मैप फ्रॉम 1:50,000 मैप। दैट इज नॉट पॉसिबल लॉजिकली। तो इस तरह की चीज जीआईएस में ना करें। सो विद दिस आई विल स्टॉप हियर, टाइम हो गया। सो आई थैंक ऑल ऑफ यू फॉर पेशेंस हियरिंग। तो ठीक है, मैं नोट्स अपने भेज दूंगा मेल करके। बाकी मेरे पीपीटी पे जो है लिखा हुआ था मेरा मोबाइल नंबर और वो सब, मेल आईडी नोट कर लिया होगा, नहीं किया हो तो मैं दोबारा डिस्प्ले कर सकता हूँ पीपीटी। तो इट इज रिक्वायर्ड, अदरवाइज आई थिंक यू है वेबसाइट पे भी देखोगे मेरे कांटेक्ट पड़ेगा। तो विद दिस थैंक टू आराधना मैडम for inviting me.
So thank you so much, sir, for taking out for this wonderful session. Actually, I will appreciate your efforts, and you showed us the potential of like what is possible in GIS, and definitely it is going to help in the coming session of the program also. Like we'll be knowing more about these tools and more about these possibilities and potential of the software. Sir, I'm so much of thankful to you. Like I can understand you are a busy person still, besides your academic and administrative responsibility, you took out time for this presentation. Thank you very much, sir.
Okay, thank you.
It was a wonderful session, sir. Thank you so much.
Thank you.
Thank you. So we'll break for lunch, and we'll reassemble at 2:15. Like what we are talking during all these sessions, like we'll be working, we'll be downloading and installing the actual software, and we'll be starting the actual work from next sessions. So kindly be there sharp at 2:15. Is it okay for everyone? 45 minutes break is fine?
Ma'am, can we join after 2:30? Is it possible?
Okay, actually, okay, you try as soon as, like, as earliest possible.
Okay, ma'am. Okay.
Okay.
Thank
So there's also one more important announcement. Actually, we'll be sending attendance link 2 times a day, like before lunch and one at the end of the session. Kindly just click on that link and mark your attendance for every day. Is this
And will be
clear?
mailing it to us,
Yeah,
or
no,
you
no.
will send in the
We'll be
WhatsApp?
sharing in a WhatsApp group only.
Okay, okay.
So I hope all of you have joined the WhatsApp group. If
Yes, ma'am.
someone hasn't, kindly join. Okay, so thank you very much for your patience and the interest shown in the program and listening very patiently. And I wish you're getting your expectations met. Okay, you can always provide feedback to different sessions. Okay, so we'll reassemble at 2:15. So thank you, everyone.
Thank you, ma'am.
Thank you, ma'am. Thank you, ma'am.
Thank you. Thank you.
Thank you.